Namaskar, good morning, good day. This is Suraj Singh speaking Bharat, India, and July 30, 2020. One more day of life. Life is every day reduced itself. Every day it is reducing itself. It's lengthy, longitude is reduced. So I'm speaking on behalf of profession, for professionals and for others. Just to let people understand about engineering and various issues related to engineering in its field, and this is certification of chartered engineer for Chartered Institute of Engineers India, Chartered Engineer India, and previous certificate is this has been, you may say this is or you may say this is like can say start, understand, or you can say this is this and this is that, it's like so I just keep it down just for entertainment, some enjoyment, some track on this. And this is again same simple management, simple paper, simple life, indication of simplicity. Life is like this, real life is this, all others are artificial lives. This is direct language, this is not machine language. I believe in direct language because machine language is machine and I am also machine. So this unique or real machine language, other one is digital machine language. That's the difference. We continue as such on this issue, management, engineering and life. Usually we say that, and life is not what we think is life, because we are materialist people, so we only think is material. We think material is everything, while material is not everything. Material is not everything. This is SARS2 impacts on and it's working itself. COVID-19, God's act of virus, engineering. This is engineering and management and system and general decisions and now human thinking. This is very important point. I have to say something about that. Human thinking, because think and think and think and think, and if you do this, you will keep on moving and damaging. And thinking only result and general and concrete specific total system, quality structure, soil engineering, which we are immensely talking these days. And FIDIC, of course, I will have to take up this issue. FIDIC, very important one for engineers and for others. It's not simply because we want to say it is a necessity of profession for all engineers, and if they miss this, they miss a half engineering, you can say. If you miss FIDIC, you miss 50% construction engineering, 50%, because without FIDIC, nothing can move. FIDIC, I mean, say contracts. Without contracts, nothing cannot move in profession. Even if you are design engineer, you have to understand these points very well. Now, I really take up issue further. Just for 2 or 3 minutes, I talk like this for introduction purpose, because I have talked. I have to take a few hours for talk every day, which talk is essential for public and to my friends all over the world. Engineering, management engineering, both are used words. When I say engineering management or I say management engineering, different ones. Engineering management I'm dealing with, though it's not alone engineering management. Specifically, engineering management applies to whole world, all time. If you take it's just technical engineering management, now words are very different, having wide meanings. All words. When we talk of engineering, means we talk particular engineering, or you can say engineering as a whole. And if you consider engineering as a whole, means it is something whole, or WHOL whole, which means it includes every sector of your life, every walk of your life. It may include society, it may include economy, it may include your nation, it may include world. It may include development, it may include, whatever advancement we want to take, what applications we want to do, and we want to promote those applications. The applications are based on sciences, and sciences are based on innovation and research. So after all, engineering is a science, it's a part of science, it's a science. It's applied science, you can say applied science. Science means system, and system means knowledge, and knowledge means nature. You can sequence like that. If you say I know science, this means you know systems, and if you know systems, this means you know some part of nature, and if you know nature, this means you know something and everything of something. There's a difference between what we see and what we understand. Sometimes we see something because our eyes can see only, our mind can see only through our eyes. But what we understand, there is a difference. Means we say, if I have some understanding for same thing, you might be having different understanding, and that is required. Because actually, it depends upon analysis capacity of each individual. How do you, what effect you understand something? For me, something is one thing, for you, something another thing. Or uncertainty is with me, uncertainty is with you. I am not sure you are sure, or I am sure you are not sure. Depends. It depends upon my intellectual capacity, what percentage I understand. Maybe I am even 1/3 to your intelligence, or you may be 1/3 to my intelligence. It depends. Intelligence has no patent. It's your capacity to develop. It depends upon practice of your mind, practice of your brain in life, what level of intelligence, what level of thinking capacity you can develop. I am using simple word, and that is thinking. I am not using very medical word or very some specific word. I am using this thinking because this is for everybody. It should apply to everyone. Thinking is a wealth given to everybody. Even animals have this to some extent. Dogs can think, to some extent cat can think, and to some extent buffalo and even cows can think, to some extent, at least for their survival, for their safety, for their food. All these animals think. Dogs and cat, they want to be secure, that's why they think. They want to get food, so this is search for food. This means some degree of thinking already they have. We cannot say because they are animals they cannot think. They can think to some extent, they can talk to some extent. We are also animals, but we are having bigger status of animals. Animals survive only for food and safety, and we survive for killing others. Simply, negativism is better than talking positivism. We know all positivism, but we are just like animals conduct. They don't want to see other animals or other class of animals to come into their zone. Similarly, we are of that nature. I don't know reason behind that. We are all from same family of God. We are from same air come. Still, we have divided ourselves. We have divisioned ourselves into many sects and many castes, and I don't know what's reason behind that. Why do we do that? We don't want to live simple life, and simple life means we are all children of same God, and we should enjoy this earth and do something for this earth. And that's my basic principle. If you think that way, that's what I'm thinking is very important. If you think this earth does not belong to you, your problem is solved. If all people, all world peoples think that they are temporary here, and you keep in your mind that there is there's no longevity here, a very small period of maximum 100 years or 120 years or 20 years, you can't stay here more than that. So why do you think that this is your permanent property? It's not your permanent property. So I should say, I understand engineering from that point of view. If God has blessed on me engineering status, engineering profession to work, I should be thankful to God that God at least believed in me, trusted in me, or someone is a doctor, God trusted in me, or whatever you are doing some constructive work for society. This means you must be having blessings of God. That must be certain, that must be, admitted that without God's blessings, you cannot do anything. Even your body energy won't help you if God does not bless you. So you are a blessed person, everybody is a blessed person. We forget that coming to earth itself, having your soul in this body, itself is blessings. Now there are other problems which make us difficult to have difficult life. Those problems I'm not discussing in this talk because those are nothing to do with my subject of engineering management, or you can say world of engineers. Though world of engineers is not very united to something, but engineer is a director in itself, an author in itself. Engineer is an examiner in itself, and engineering is a worker in itself. I am engineer means I am a worker. I am a worker means not worker of that rank, I am diplomat or I am sitting in political position. No, I am very small worker, you can say educated worker, educated labor. This labor I don't like to say, but people use labor or labor. So I am also labor. Because if I lead those that crew of laborers and they accept my commands, they believe that I am an educated one, and they believe that I help them to do job, I support them from higher level, and they move because of my support. They would respect me certainly, because ultimately everybody knows something only. I also know something. There are much better people, many thousands of much better people than myself in whole world. What I am, others know, but there is something which I am, only I know. That is privacy, personal secrecy, which everybody cannot know, and this cannot be revealed to all. Means what's my nature? One nature is professional nature, one personality is professional personality, but there are so many secrets in life which you know only, and this applies to everybody. So that is a hidden part of your management, because that helps in management as well. What my secret is, of course, I know that. Others may not know that, or only very close friends may know that. But that helps me. That's also important. Sometimes, some people do something, lot of what they do, but they don't want to show that I have worked or they have worked. I think that's brilliant, status of a person who does a lot but doesn't show all that. Because showing doesn't give anything. When work exists, you produce something, work is delivered. Everybody shall see that. Simple. Sun cannot be concealed, sun cannot be hidden except momented by some clouds, and that's also shade. Light of sun still is visible behind or beyond transference of clouds. So engineering, as far as profession is concerned, is okay, but it's also another part of life which is non-professional. That part is genius part of engineer. Means one part we show to public, this is our product, we have done it, we have delivered it, but there's another part behind that. That is visionary part. That is imaginary part. You consider as horizon, or that's mirage. Just like we say in desert, you find mirage, or you find some kind of rainbow in the sky. You can't catch that. And also horizon, you can never catch that. So you may say horizon you are having, which others can't see. Mirage and rainbow you are having, others can't see. And intellect you are having, which all sums of this equal intellect. Intellect is a must in every intellectual person, and I should not say only intellectual person, in all persons, maybe of lower degree. I have observed on sites during work that even those who have never been to school or college, all nationals I'm not talking our nationals, I'm talking Pakistan nationals, Sri Lankan nationals, Bangladesh nationals, Philippine and Thailand nationals. I'm talking from workers, I'm not talking from managers. Because managers never come from England and America. Workers never come from Canada, America, or England, or Europe. Only these Asian countries are recruited workers. And I have searched in many of them, those workers, that they have some degree of brilliance somewhere in their mind, provided they are imparted particular training for that tact or that technique, and they wonderfully apply that. This means somewhere they want to grasp something. Everybody of them wants to grasp something if they are allowed to learn. Yes, they may not express in English, they may not be able to write something, but they do that. So it doesn't mean that they have not gone to school or university, they cannot understand. They understand if you are taught properly. You also understand because you were taught sometime in your school life or in your educational or higher education life. You are engineer because you were taught something. You are trained, that's your engineer. They are not trained, but they have a capacity to understand. This is there. This is why I am saying think is very important. I want to use think, not brilliance, or not contemplation, or think for everyone. Think and thinker. Thinking. And in past thought, thoughtful. I say I am not a thinker, but I say I am a thinker. Because this talk itself justifies that I can think. And thinking is not very high quality at all. This is basics of life. You must have that. If you are a living being, if you cannot think, you cannot do anything. Some people say God will do on my behalf. God is already doing on your behalf. Don't expect more from God. God is already doing on your behalf. That's what you are ignorant here. God has already done, but you have not understood. First God has done that, has given you body and soul. This itself is God's blessings on you. You are living in this world. You have been brought up in this world through your parent or someone. This is also blessings itself. But points come in, are you independent? Independent not in style, independent not in standards of living, independent in your approach, in your resorting to responsibility acceptance. Do you take responsibility? Or you want to run away from responsibility? I don't understand many people, they are scared of responsibility, scared of obligation, scared of accountability. Why do they show like this? I don't understand. There is nothing difficult. Either you are a fail or you are a pass. Nothing else. If you are a fail, it doesn't make a difference if you are pass. Fail or pass. Everybody cannot pass all time, and everybody cannot fail all the time. Sometimes it happens you fail, and sometimes it happens you pass. So what? It doesn't mean if you fail, you don't know that subject. Yes, you failed because you did not prepare well. Subject you know, you studied that, but you did not concentrate on that, and you failed. If somebody says there is 50% marks of failure, there are 35% of course, but let us assume on an average there are 50% marks on for purpose or justification of pass. This means if somebody is having 49, that person fails. This is technically, this is arithmetic wise. But 49 and 50, there's a difference of 1. So if that person knows 49, by chance he could not remember for 1, so that person is failed. But does that person really fail? Because that person knows 49 already. And that person is not promoted because of shortage of one number. So no problem, next time that person passes. But that person who got 50, if that person passes, there is no difference in them. Some environmental difference there is, or some other reason there could be that that person got one more at the. So I say it's no different. It's chance. When you have competition in sports, number 1, number 2, number 3, it's always say, and there's no major difference between 1 and 2 and 2 and 3, minutes or seconds difference. So it should be considered as if failure is not a failure as far as your will does not fail, will, W-I-L, as far as your strength is not failed, as far as your destiny is not forgotten. Failure should be welcome as much as pass is welcome or success is welcome. Failure equals success and success equals failure. When you fail, don't be depressed, because failure is also a part of life. Thinking says that. And I tell you, everybody fails in life. Yes, maybe you don't fail in your education, you pass your schools, all classes without failing any year, or you pass your higher education without any problems. That is only academic part of life. Added to that, on top of that, there are so many parts in life other than academics where you are tested every day. That test is much more important than your academic examination, because you have an opportunity examination, you have preparation time, you have clarification time, you have reference time, resources time, and you avail those resources to pass that. So you are having some rich factors there. The resources you have, only 3 or 4 hours or whatever examination duration is, except that your time and time and time. So there you are supported. You are supported by teachers, by professors, by the library and by online system. You have various resources. So there is no dearth of that. And if you pass, it does not mean you achieve, because you are supposed to pass. But it starts where? Difficulty in your career, when you really take independent charge or even associated charge, both. Associate charge also to some extent independent, but in school and university you are dependent on your teachers, you are dependent on your guides. Even if you are doing PhD or MTech or some other study, you are supported by institution and by scholars. So you are not alone there, someone is with you. So your thinking itself is limited by guidance of others. Your work is even vetted by others, and you are told, you are instructed what you should do, what you should not do, do's and don'ts. So there it's not your accountability, it's actually accountability of those who guide you. But when you start your career, if you start your career, it's completely different world. I enjoy that because I have an opportunity to work independently to some extent, and later on you with higher positions, you work fully independently, at least technically if not financially, because in beginning you won't get financial responsibility, you may not get this decision making responsibility, but you may get some responsibility at least to work, to with reference, of course, you deliver something. You may be guided by something, not 90, not 100%, maybe 1%, and then you have to pick up yourself. So what you learn on job, is based on your thinking, your initiation, your original action, and then you deliver. You deliver something. That action cannot be forgotten. If you do something extraordinary there, you take your own decisions and write some queries and get answers. You will feel a degree of pleasure. Yes, I thought on that, or I discovered that problem. I sorted out that through your proposal and others' acceptance. And that's the kind of recognition you can say. Though it's not certified, but you feel that I am getting something additionally than what I learned in university or school. That is called, you can say, step by step success. And within that success also there are lapses, sometimes, many times, and I don't mind them. If there are no lapses, means you are not successful. If somebody says, I have never made a mistake, then that person lies. It's not possible that you may not make mistakes. Everybody makes mistakes, but yes, repetition of mistake is not acceptable. I can make mistake. There can be misinterpretation of something because I'm not that experienced, or I could not understand that subject because it's technical and I miss something. I start doing without, because I was under pressure. I was on a time limit, so I opted to do something, and we'll see later on what to do. That doesn't work. That doesn't. You wasted actually your time. So what I mean to say, think is root of development. Think is root of engineering. Think is root of profession. Think means really thinking, not just thinking. I'm thinking for sake of thinking. No, that's not true. You have to think for sake of actions, for sake of making decisions. You have to think for that. And if you are in job, you are thinking, you are paid for that. And if you are not in job, you are in your own life, then that is your bonus. You can think whole life, whole day. Even you are free, you can think. You think of your job on your duty hours, and you can think same job when you are at home. So you are thinking. Thinking is special. Just you can say there's one Internet of Things, that is, means think Internet of Things. There is one, I mean say discipline. There is thing at THING, but thing is there. Thing is very common word. Things and things. Some people use thing when they don't find anything. They say okay in this thing, because they forget name of that item or they don't know what is that called. So they just, to avoid that misconvenience, they use thing. And I use think. Both are different. But think is common one. Everybody can think. Because in general language, okay, I think so, you think so. Do you know I think it? Yeah, okay. If you ask a question, someone says, I think so. I think it should be done that way. Means there is no surety on that. There is no warranty on that answer. But it applies here on low profile. So keep thinking, word on low profile, but use it on intensive profile, high profile. So don't go to contemplate, don't go to some higher position. Okay, thinking. Believe me, once you start thinking, then you become a thinker after some time. Only problem is we don't want to think, because we have a lack, we have a low degree of decision making. In 90% of people, decision is very important for them, but they can't make it because they are little ignorant. They don't value time. They don't value professional objective. Every profession has some objective. Every profession. I'm not talking of objective of degrees, additional degrees. That is very common. If you have 3 or 4 degrees, 2 or 3 degrees of different positions, say higher or lower or equal, that is your personal. How much you learn in that, that's your personal. I cannot say you pass and you got something. I still remember one of my colleagues in very long time back when I started my job, and that person, of course, in same status as I was, and still I remember that person. Then I was doing my higher education, And of course my aim was to pass subjects, because without passing subjects you cannot get your certification. But that person had different approach. Used to say, ask everybody, oh, you have passed this. Yeah, you have passed this. Okay, you have passed it. You are attending class. Okay, you are attending class. Are you understanding subject? Are you understanding subject? You are just learning it for purpose of passing. So his objective was to pass, but that person's objective was not to pass, but to understand certainly what you are taught. If you understand what you are taught, for that person, that was objective. That person did not worry about pass or fail, but that person who intended to learn everything. That person intended to learn everything, and that was important for that person. That person had no interest in just passing. Passing was necessity, but learning was significant, more significant than passing. So there is an approach. It doesn't mean that that person would not pass. He had to pass, maybe a little delayed, because that person wanted clear understanding of subjects. Conception should be clear, and I believe that approach. Yeah, if there is efficiency in passing along with that, that's very good. Oh, Sham, get lost! Yeah, what nonsense this is here. Just for nothing here, just calling for nothing and disturbing me. Nonsense. So what I have to say here, that thinking is not a verb alone. Thinking is no adjective. Thinking is no part of speech. Thinking is base. Thinking is foundation. Thinking at time of education is different. Thinking at time of education is different. Thinking at time of education is completely different. Thinking at time of work and thinking in life for applications is a different world. It is thinking that brings change. It is thinking that brings evolution. It is thinking that brings research, brings something new. So thinking, you can say, is a unit here. You can say it is working unit. How much you thought, how much do you think, you solve this problem. What do you think behind that? Do you think something on that? How could you solve this problem? I tried this problem many times. I could not solve it. But you solved it today. How many hours did you take to solve this? I have tried many times, many days. I could not solve it. You solved it. This means that person had a concentration of thinking. That person could understand basics of that. Because that person took it seriously and I did not take that seriously. There is only this difference. Only this difference. I have seen many people, many professionals all the time, I am busy. I am too busy. I have no time even to take food. I have no time to this and that. I am too busy. I am having stress. They demand me a lot of work. I am surprised. It surprises me if somebody states that. You are a professional. Digesting stress is your activity. And if you cannot digest stress, this means you are somewhere having some weakness. Stress, tension. Why? Why do you have stress? My question to every intellectual, to every professional is, why do you have stress? After all, why? Don't you know this job? Stress means when you cannot match with requirement. You don't have that property, that character, that capability, that eligibility, but you are in job, so you can't do job because you don't know that. How to do it. If you know how to do it, then you will do it. So simple, but do not, no. You don't know that. Simply speaking, you don't know that. This is my conception. I saw many people in my life. They always keep smiling and happy and talking. What's the reason behind that? Oh, he doesn't have a problem because he keeps himself updated on his activities and responsibility. He does not leave any paper on desk and all. And whatever he has got, whatever he does with full confidence. And I have seen other people also who show a complete update and I am this professional and I am so busy. And if you say results nil, and that person done something, you ask him, explain to me what you have done, you won't find that person confidence to explain to you. But you say, I have done this. This is difference between intellect and non-intellect. Job performance. Performance is required and this all is a part of performance. Why we call it perform? Why don't we call it do it? They say your performance is not good or you are doing wonderful performance. What does it mean your performance is not good? Perform. All forms must you do. Right? Whatever form is there is a form or unknown form or your defined form from one point to another point, from one act to another act. You must do, you must design, you must fill in and you must submit. Right or not right? If you cannot do that, you fail to perform. If you do that, that's fine. There is engineering. This is engineering. To be very frank. The very start of engineering is this. The very start of academics in engineering is this. Very start. Engineering means to learn how to think and think. Engineering doesn't mean only formula. Formula are used. But we have to learn how these formulas were designed, were derived, were reached, just to make your mind work. Or we remember this formula and apply. Remembering and applying is application of doing is clerical job. Or how to understand that formula, or how to derive some other formula, that is important. We learn in engineering on all subjects. Derive this formula. Prove this formula. We can simply be said, okay, use this formula, finish. Why do you learn it? There's a difference. Understanding derivation of some formula and using same formula are different. If I say use this formula, these are values, you will simply say this answer. Right? But I say no, these are parameters, solve this problem. I won't say use this formula. You have to decide this formula you use. That is your analytical mind to decide which formula helps me this. So you have to apply additional power of thinking there. I'm not telling you which formula use, you decide yourself. I am giving you liberty to decide. I am giving you an opportunity to decide. You may be deciding what I think or you may be deciding something else. There may be different options for same thing, and that is what is required. You must have options. You must have thinking other than all others think. Or very rarely think, very few think. Engineering is not simply a word, engineer. It's not, you can say, personality or profession. It's not a profession. Engineer is no professional. Engineering is no profession. It's something else. It's an institutionalized mechanism. It's a long travel mechanism. Engineering can't be done in one day. As it can't be learned in one day, it can't be done in one day. You cannot solve engineering problem in one day. There is no engineering involved that you say, today I have done it. You take time, it's a process, it's a procedure. There are many stages in that procedure. And then you have to do something. That is engineering. This is not date of birth of my work is this. No, I can't say that. Until we understand this point, that engineering is an institution Engineering is a full mechanism, and it doesn't give answer in 1 minute or 1 hour. Just like education takes only 4 or 5 years, projects also take many years. This means in those years it's like you have to learn something, you have to teach something, you have to learn from someone, from drawings or specifications, or from whatever information is given to you intact for that purpose, or whatever new methodologies come to you, you have to learn from all, and then to teach all in forms of instructions, in forms of their work supervision, or instructing them what to do. That's internal process of engineering. And that's why I simply finish engineering statement in 2 words: design and deliver. I'm not talking about structural design, I'm saying design. Any kind of design. Any kind of, whatever kind of design. Design and deliver. Design and deliver. This is in 2 words you can say engineering is defined. And if you want unlimited definition of this, think to power infinity, missing. Think to power infinity, there is no end to thinking. There is no end to thinking. Fortunately, engineering requires a dynamic mind, very active dynamic mind, and of course very passive also. Sometimes you need passivism, as if somebody looks at your face and says, "You are not serious today, you are sleeping." One of my client, my owner, I clearly told him once when I used to visit my room, I'm sitting in, and sometimes he thought I'm relaxing. Then he used to this good morning, means he wants to disturb me, I was thinking, because they don't care a person had come. He thought that I was sleeping. Yes, I was sleeping. I was sleeping because you felt that I was sleeping. There are many classes of sleeping. One is physical sleep. One is lost. When you are lost, you are asleep. And one, you are not very active, people think you are sleeping. This is particularly, Arabic people and West people use this word. You are sleeping. Sleeping. For them, sleeping means you are not active. You are not caring for your job. You are sleeping. You are not active. Because their eyes see something which their mind cannot see. If you use your mind to see, I think you will understand everything. In engineering, I call passive time is also active time. When we make some planning, some scheme, or some schedule for work, we understand sometimes, activities are very fast, seen, done. People are moving here and there, doing job and all that, and in hustle and bustle, and all people remain busy. And you think work is moving. And also sometimes you find a period, an instant when you think nothing is moving. Nothing moving, people are there. It doesn't look to you that people are working. But they are working. They are working different way. Maybe sometime I relax. Okay, I relax. You think I relax really? There is a difference of approach here. Because we are physically oriented people, we believe in physical actions, we don't believe in intellectual action. Physical action, even buffalo can see, dog can see. But intellectual action, only intellectual can see. I am not an actor here. I am not a film one, or I am not doing drama. If I have some problem, I have to be patient. I have to think for that problem. And that problem you cannot solve if you keep nervous. I am very dynamic, say this day, and I cannot think of problems, don't believe me. Because that dynamism will not allow me to think, concentrate on that. I am doing this 10 activities today, there is a problem in 11th activity, I leave that behind, next time I'll look at this, or some other time. If in these 10 actions I include that, believe me, neither these 10 will be done, nor that 11th will be done. All will collapse. Mind has this property. When you are active, forget previous works. Forget works for which you don't have solution. Forget them. Neglect them for time being. At least concentrate your energy on these activities which you are doing so that these are successful. Certainly these are successful. So you move forward. And when you finish that, maybe you are tired, you go to rest, or you start thinking of, because these 10 have gone, now automatically cells of these activities would come down to settle, and you will start, either you will take some rest, or doing rest you think, or some other time, instantly you will find a solution, instantly. God has programmed in such a way that this machine is more stronger than your computer hardware. This machine, mind, it's more important. And mind is engineering. Mind is engineering. Mind is profession. We have to think this way. I am not psychologist. And there is no need to be psychologist. I can't be psychologist because everybody is psycho. If you are not a psycho, you can't be engineer first of all. If you are not a psycho, you can't be a doctor. Yes, if you are not a psycho, you can be a politician, you can be administrator, you can be anything, because there is no accountability. When you use mind, you cannot be all this. If you are mind user, you can never work in politics. Because intellectuals are not required in politics or in some other field where action is required, not thinking. So sometimes thinking is a passive action, just the active voice and passive voice. Sometimes I keep on thinking for hours. It happens. And I also don't know why it happens. Sometimes I feel in my life career that whole day, 8 hours, 10 hours, I kept thinking. Believe me, it happened in my life. Whole day thinking. Of course, I was maybe on holiday or vacation, thinking. But wonderful results you get. Wonderful results. Means when your mind is in thinking stage, not in working stage, you don't know what you want. Believe me, you don't know what. My mind steals. It steals files somewhere I don't know. And tells me this is that. Did you ever notice? Never. Because you never thought. You never thought. Thinking is process of research. Thinking is process of innovation. And thinking is different. Thinking is different. Working is 1. Thinking is 10. Because just think of computer. How could it be developed? It took time. But today you find computer and you find yourself. Which one is superior? You can say physically computer is superior, of course. If you compare physically and mentally, physically computer is of course superior to me. Because it calculates for me, it gives me data when required, immediate data it gives me, and not one thousands and lakhs of data. And it makes me a problem. Because so much data it gives me, it takes time for finding out which data is best for me, or it tells me something which I don't find is best. This means it works, but its work is according to its movement, according to program that is fed into this, not to my mind. My mind does not accept that sometimes. No, I don't trust this computer. I don't trust this computer. Now what is happening actually? Computer has impacted our minds in a way that we have stopped thinking. Will you believe it? Computer has abused our minds. Capacity of writing, skill of calculation, and skill of vision, and skill of many other valuable propositions have left our lives. And when, in fact, to be very frankly speaking, because of computer, we have become operators of computer, we have become clerks of computer, or can say coolie, what they call helpers of computer. We think data feeding is important and results we are getting this. And this is in every field. We have forgotten telephone numbers, we have forgotten formula, we have got everything. So much done in secret, in behind scene. It works on automatically and we don't know what's going on, but we believe results. This happens. It is not in my control, not in your control. This is natural now because of computers. So I'm not blaming computers, I am blaming myself. That I am so anxious of computer that I can't work without that now. Certainly not. Computer is a mechanism, is a tool, but unfortunately, computer is a leader now, and I am tool. I am a follower. That is where world has changed. World has changed now. We have lost thinking capacity. And that's why you have stress. Because you are not thinking, you have stress. Mind is a house. Mind has some hunger, like everybody has hunger. Everybody has stomach. Mind is also stomach. It's also having a stomach. It's also having its need. If you don't fulfill those needs, it suffers. And that suffering is converted to stress. That suffering is converted to depression. Depression is, I am depressed. You are depressed because you did not get what you wanted. You did not get that. You are depressed. You are working, you are making money, but you are not feeling happy because you are not getting something for your mind, and you are so busy in your work, you have no other field of understanding. You have no other field of approach. What used to happen in past, when there were no computers, we used to refer to stories, used to refer to some other knowledge books, or like you can say, for entertainment purposes, some novels we used to read, or some newspapers we used to read, or something else depending on your hobbies where you are fitting. And interactions used to happen everywhere. Interaction, talks, meetings with each other. It transpired information from one to other. That lifestyle is no more. That lifestyle is gone. Our life is, this is social engineering has gone. A society that was composed of everybody practically has gone. What is left is non-practical, non-physical. We deliver everything as if it's machine, not human. You can see it complete difference in drawings, designs, and work on site. You see a difference in drawings. Those times were there when there was no computers. Drawings were real drawings. Real drawings, somebody used to draw them and give them. For purpose of what? But now there is no such requirement. You are getting everything through computer. You are getting more details, more redundant details you are getting sometimes, and sometimes you are getting not even complete details. So you don't know what to give to site, what not to give to site. And what happens? Because of time schedule, time controls, site people don't like all this, but they are given. Still, despite so many details are given, quality is lapsed. Quality is there. We should think why. See, again comes to thinking and super thinking. We have to find out solution, but we do not find solutions. We do not find. You must be noting now, every day, every time, and yourself too. Writing has gone. Writing has gone, number one loss. Reading has gone, number two loss. Interaction has gone, number three loss. We are dependent on what? Seminars, online webinar, we call webinar. Even signatures are not required. I find now problem in writing. My writing was very fast when I used to write. Writing and writing and writing and writing. I used to go for typing many notes, many correspondences, draft. I used many drafts every day depending on work. Sometimes even 20, 30, 40, 50 drafts depending on work, small or bigger. So I used to write a lot with my pencil and give to a typer. And typists could not type because of huge pressure on typist for everybody who has to type. Because typing skill which everybody didn't have, and people do not sit on typewriter to show I'm not a typist, I'm an engineer, I'm an officer. But they sit on same now. Same MS Word, they type, or some other program they use for typing, and they don't feel that they are working type. This is only difference, because now you feel I'm on computer, I'm doing computer. Still you are typing, to be very frank, you are a typist at that time. But only difference is now you are not writing separately, you are thinking and typing. I have seen still some people who write and then type. It's up to them, but actually you are thinking and typing. That is added advantage, but you are lost is that your damage is you are not able to write, and this leads to wrong spellings. This leads to, you can say, memory problem. Writings is also a memory. If you write by hand, you write in your mind, to be very frank. If you write 4 or 4 times something, it occupies place in your mind in memory. But now there is nothing as such. So there is a change in engineering of standards. It is good as well as bad both. It has merits and demerits. You used to teach your kids or some other people. Now you are not teaching them, or you are teaching them in a different mode, which is not intellectual mode. I should not criticize all this. I'm just explaining what's happening. I'm just trying to explain what's happening in this world. I have seen many people, British people, write using capital letters because maybe they are not practiced to write with other letters. And this has been a change throughout. I am just describing this to connect to our engineering world. Engineering world is not that easy as we think. Engineering world is different in the sense that it's concrete world. It's not imaginary world, it's not a talk world or lip service world. Engineering means you have to deliver. And if you cannot deliver, there is no meaning for engineering. It may be design, it may be work or whatever. If you cannot deliver, engineering doesn't work. You have to deliver. So my point of view is very different. We have to understand engineering from practical aspect. That is engineering. Lot of computer programs, lot of things. I think now computer programs are much more than engineering work on site. Everybody wants to be designer. Everybody wants to have higher degree. Everybody is interested in that. But I am finding those who are interested in real work. And I am finding a problem in that. Very few people are interested in real work and realize that you are not making engineer actually now. You are not making engineer. Fact is that. Because without work on site, frankly I am speaking, without doing work on site, without experiencing real work, you can't know engineering. Just a design is not adequate. Just you know, just some procedures are not adequate until you experience activities on site. I don't understand why people think that they should only sit in office and design, and they have higher minds, so it's their job. This is difference of philosophical understanding. Real job is on site, in factory, in industry, where production moves, work is done for purpose of production, for purpose of delivery. That is more important. But unfortunate that our engineers, not only all our engineers, many other countries' engineers, do have same opinion that I am a designer. I differ here. With regret, I differ here. And because once you work in field or you experience, you will understand problems. What problems are felt by field people, how they solve those problems or they do not solve them. Both are there. Either they ignore those problems and do work inaccurately or substandard, or they say, if somebody asks me, I would say, yes, I followed your design. So that thinking is damaged quality of work. We should not forget, if you are responsible for design, you are also responsible for quality. Quality moves together with all works in engineering. If without quality, you cannot do anything. Quality is a must. And if you don't do that, your work is incomplete. You cannot claim that I have designed and this is responsibility of others to ensure quality. I do not agree at this point, because foundation of this thinking is wrong. And I respect site work, believe me. I respect design work as well as site work, because both have their respective importances. Site work tells designer what you have to change, what you have to think for future. Lessons come from sites only for designers. They don't get lessons from somewhere else. Real lessons. I'm not saying lessons to learn more procedures of designs or more application of formulas. I'm talking of what problems are expected and experienced on sites are real inputs for designers, if they have, which is called lessons learned. Because design should meet working culture. Design is not just design to show to others my drawing is very significant, you see quality of this. Quality of drawing is one part, but application of that one is another part. I'm talking of application. Design is excellent. Your drafting by computer is very nice. Your design, theoretical design is very nice. Everything is nice. It's nice for purpose of design and drawing. But is it nice for purpose of implementation, for prosecution, for really converting your work to physical shape? Where point lies in? That's what I'm saying here. I have experience, of course not thoroughly, I have some experience on site, some experience in office work, some experience in contracting, some experience But mysterious types of experience, fortunately, do I have. I have no pride on that. It's my job. Engineering part, everything is engineering. If I do work in design, that is engineering. If I do quantification, that is engineering. I mean the quantification quality, I'm saying computation of quantity is also engineering. Estimation is engineering. You may say procedure writing is engineering, method writing, or you may say work on site is engineering, and you can say programming or planning is engineering, or you may say whatever you can say. All comes under roof or umbrella of engineering. I cannot take out anything from there, and if somebody takes out that person is not, they have not understood what engineering. Either of these, even if one you take out one point from this, oh, you can't say what shall be delivered. My statement doesn't say that designers are wrong. I don't say that. Designers are never wrong. Only approach is sometimes wrong. Just thinking my design is given, I have given design and that's my job, or that's end of my project. Let site person here. Here I don't agree. I don't agree. Remember all designers, all, you are teacher of site. You are teacher of site engineer. You are instructing site engineer through drawing what they have to do. And not only site engineer, all others working on site, all others. You are instructing all trades, skilled tradesmen. You are instructing everybody, supervisor, foreman, everybody there. Not directly, indirectly. If those people do not understand what you are telling them or what you are instructing them, it's not superiority or inferiority question. It's question of communication. Your drawing should be such explanatory that work should be easily done. Work should be easily done. Based on your drawing should be that much competent, consistent. I have seen drawings, computer-based drawings and all others. Of course it takes time, I cannot say that. It takes a lot of time. Not only drawings, even studying drawings. When I study drawings on some project, believe me, it takes many months to go through all drawings. Sometimes it has so many drawings. And drawings is one part, then specifications. I think many people, 70-80% people miss reading specifications, standards. And many people, generally 98% people miss even knowing what is contract. It is not educational exam. You have to learn everything. Engineering is that. You cannot opt out of everything. Now, I opt out of this, I opt out of this, I do only this and get my job. Can't. That is why engineering is different. Engineering management is different, and management engineering is different. See, engineering management is real part of ourselves. When we say engineering management means you are a manager in engineering, you are working in engineering on your decisions, you are making decisions, and that's management. Making decision management, procurement management, how to handle human resources is management, organizational management, organization you can say. Everything that you are doing in field is organization at a small level or at big level. This is organization. We should understand this point. And thinking is root of that work. You are thinking from commercial aspect, technical aspect, or sustainability aspect, or compatible aspects. Comparable, yes, so this is compared to that one. Everything is engineering. You have to make this understanding clear. You are a part of team. You are not a separate team. You are part of a team, engineering team that works on site or on project. Being a designer, yes, you are not everyday part, but your design is a part. So when your design is a part of that team, you are a part of that team. Indirectly, you are a part of that team. Silently, passively, you are. They are follow your mind. They follow what you draw, what you decide, you design. They follow that. So you are, you can say, virtual part. If your drawing is mistaken, your drawing has errors, certainly there will be errors on site. They won't, problem is those people can't go to that detail as you have gone during design, and maybe now you are not clear of what you thought at that time, because you are not handling one project alone, you are handling many projects. That's my point of view in engineering management. Means every day I talk something about, and I feel that I open my mind, I open my mind to you, I open my contemplation to you, just to make you think what I missed in my life. I cannot say missed because that life was different at that time. Facilities left life. No facilities those days. Now everything facility. So you are benefiting from these facilities, but you are not benefiting from your only facility, that is your mind. Don't forget whatever you learned in education also because of your mind, not because of something else. So use it. Better than drinking whiskey, or better than taking drugs, is use mind. Better than spoiling your time, use mind. Society won't give you anything, you have to give to society. Society won't help you, you have to help society. Society, when I say nation or others. If you want to help society, you have to keep yourself safe and clear in your approach, in your mind. If you don't do that, forget. Engineering is not a profession to earn. It's not a business to promote, though it is written in charter to promote engineering. This does not mean to promote commerce. This means to promote development of world. This means just that. And engineer is privileged person, privileged professional, because without engineer, nothing can move, remember. So it's a different profession, and you should respect your profession. Even if there's no registration say, there's no command say, yet you are, without you can't do anything. Without you, they can't do anything. You can't do anything. Coming back to talk of soil engineering. Soil engineering is very basic fundamental engineering, and in fact you cannot say this engineering alone. It's not alone engineering, it's nature also. When nature is involved, something very basic is involved, something which is beyond your control is involved. You cannot simply finish a statement saying this is engineering, though we are calling soil engineering. There is no other way to express that. Soil engineering or soil mechanism or rock mechanism or foundation engineering. You may use any term, you can use whatever term you wish to use. But in fact, this is beyond that. Beyond that. Much beyond that. Because it is part of nature, though every other matter is a part of nature, but we extract something and use it. Here we excavate something There's a difference. Extraction of something for use and excavation of earth for foundation do not meet each other. When you excavate, it's considered means something nothing now. Just excavate only for excavation so that we can do foundation. That's only purpose we have. But we forget that whole life is dependent on soil. Whole life. We are not flyers. We are not birds. We cannot fly and go on tree and sit. We are human beings. We have to live on soil. We have to walk on soil. We have to sleep on soil. Though we sleep in bed, but we are sleeping in the soil. This point is not engineering point. This point is real life point. And whole world does that. Soil is generally ignored by engineers. I don't know reason behind that. Soil is considered as we'll see, or we assume something. Means public also as owner of projects or of their houses or their structure do not respect this, because there is a convincing problem. There is a problem because people do not know importance of that. People do not know. If even you ask someone about that, they will take it differently. What nonsense they are talking? Soil test, soil. Soil is soil. It's not their fault. It's fault of those who are supposed to teach them, not fault of us. For them this is soil, this is true. Because we do not value soil, we value it negative. It's dust for them. It's dust for those people who do not understand that soil, what's purpose of soil. Purpose means they think only that excavate and make your building and that's all. They do not understand anything, because they are not professionals in this field. Soil is not their subject. But those whose subject is soil also, or it is must to be a subject, those people do not care. I am not going to backbite those. It does not carry any fruit. If I backbite also, there is no meaning behind that. But it's my duty to talk to them through this media. And they know soil is very important. They know, and if they do not know, they shall know. No soil means no civil engineering. No soil means no life. It's beyond your control. You can't do anything. You have to accept soil as a material, permanent, super permanent material, ever changing material. This material keeps on changing, but your concrete, your wall, all those issues did with lot of work, lot of research, lot of testing, that may not change to that level as your soil changes. Soil changes horizontally, vertically, dimension wise, space wise, chemical wise, temperature wise, heat wise. It keeps on changing. Soil is a denser, It does not tell you what it is doing. It does not care for you. Soil is that. It has many gases within it. Air is its gas. Water is gas. Heat is gas. Coal is gas. That is soil. It has many gases with that. And those guests are good or bad both. Those guests are sometimes good for it, sometimes bad for it. And same soil gives you food also, don't forget that. Soil gives you food, soil gives you flowers, soil gives you plants, and soil gives you your foundation, support. This is soil. Soil, when I say soil, it includes rocks, it includes sand, it includes clay, every part of this material which you take from earth, directly from earth. Interesting to analyze that. I started talk of soil because of this reason only. Because some professor told me that soil is not a part of engineering, or it's just nothing in engineering. You have to study that, and everybody does not know it. I agree with that. Everybody does not know it. That's okay. But this is not a part of engineering. I don't agree with that. Soil is only part of engineering. Other parts are not engineering part. Soil is only part of engineering. If you understand soil, forget formula. Forget how reaction comes from soil to water. Forget everything. Forget it. Just say soil is there and use it. Can you use it? Cannot use it. You need complete details of that. And that detailing is really intellectual. You simply cannot avoid it. I did not test soil and I am not responsible for this project. If you say like that, then you are not an engineer. Even if you assume something, this is your responsibility. Because sometimes you have a capacity to assume, being your experienced person. You might have experienced similar foundations or some, so you say, okay, I take it, consider this one, assume that this is that. You also know that the building won't fall, it won't fail. We know that. And that's the only reason is sometimes where we should do, we don't do. And we have little knowledge of soil, and of course we don't have equally little knowledge of soil which we do not know. We don't want to know. I was talking of thermal resistivity, electrical resistivity of soil, which is very important part. And before that I talked of many other issues, many other properties of soils, popular soils, and we talked of, soil stabilization, and we talked of about mechanical stabilization, cement stabilization, lime stabilization, bituminous stabilization, membrane stabilization, electrical stabilization, thermal stabilization, chemical stabilization. We talked of this with many details, and also we talked of various data of particle size and various other testing related talks like and other issues, how to mix up two grades of soils to reach some other design status. We talked of that, and we talked of your talked of electrical and your thermal and chemicals. Yesterday we talked of thermal. Now we talked of many other chemical issues, chemical solutions, and which we talked of stabilization with calcium and sodium chloride and lognin and cromolyn, and like that we talked of. And there's something left in that, we'll try to talk it. Then talk of soil investigation, and we'll do that, soil investigation, which is very important part of engineering. soil, and we will take. I'll come back with this all. Now we'll take here that file open which I was talking yesterday. That file I open now. That file is here. I also other files which I start after this. So these are files related to soil explorations, value of iron, and also clay minerals as Mount Morillonite. I got some files which I discussed with you yesterday. This was thermal resistivity talk, which I put also one URL which is associated to this talk. This file actually, that is, we associated or linked or caps this screen share with video, regular video, and I'll do that for some other files also, because I have to talk to you about soil reporting, soil report or soil exploration. Those reports, I have practical reports for these two projects. I want to actually confer with you on those reports, because those are practical reports done on site. Those cannot be defined by anybody. There's no imagination in that. They are real work reports, and that can teach you better. That can give us information, practical information, not just academics information. This point we have to understand very well. Life is not as we are finding. So in this I discussed yesterday, and it says simply, don't guess everything, measure everything. Guess is not engineering, guess is not real work. You cannot depend upon guess. You have to take tests, you have to do the conduct test and find answers, find reports. That's what it is. So in this there is a thermal resistivity. What is that? We have tried to understand how it is represented, what does it mean. We did all that in our thermal resistivity file. I'm sorry, just a minute, I'm just sketching here. This is for, it was little, some pages were left yesterday. I like to complete that. This is thermal resistivity, and then we talked about what is theory behind this, what is measure behind this, and studies and references. Then we talked of theory again. So this is theory, and we talked of never use standard values, understand water content, density affect RHO, and RHO must be measured, consider site specific variables, and then we use theory, never use standard values. Then we talked of look at variables. Thermal research, we talked of this thermal research. Then what to learn from models, and we also studied about graphic variations on quartz, loam and organic materials in various figures. Then also we could go to water contents, and then critical water content, and of course some graphics on that, and density affects RHO, this we discussed, also graphics, and besides grading counts, 6 lessons data discussed. Then RHO must be measured, and then say consider site specific variables. Consider site specific variables, and then we want to again measure now. Measure solutions, you can say that was theory. It's now measure solutions, and we discussed it. These are also very important. 2 ways to test, and then said lab testing, create a dry out curve. Create a dry out curve, and then there was Now I think we should be here at drive out cut, create a drive out curve. We should start here again, and then things to keep in mind and reporting RHO, and then data contents like this public utilities. So we have to restart here at this point. That is, I think, drive out curve. Drive out curve top page 16 and create a drive out curve. Desktop. Just a minute, I go for half a minute to see weather and also feed. I forgot otherwise to feed is crows or the zoo. I don't forget otherwise, I don't forget it. Let's go on that. Job for that. Sorry gentlemen, just a minute. I'm now going to do that. Talk to you, create a dry out curve. Yesterday we talked, it's not complete, let's complete today. And then I'll start also on Mount Morillonite if I could do that today, because that's also a very important part. Now it's create a drive out curve. Create a drive out curve. Let me blow it little. Yes, create a drive out curve. It says thermal resistivity of a soil depends on its water content, bulk density, temperature, and composition. For a soil in place, composition and density are fixed, and and temperature typically varies over a narrow enough range to have only a small effect on thermal resistivity. This is not case if soil freeze during cold months. Now it says what? It says that resistivity, heat resistivity, you can say thermal resistivity of a soil depends on number one, water content. We agreed that yesterday we did that. Water content of soil, and therefore also bulk density of soil because of reduced air voids and compaction or packing of soil. You can say density can change, but it depends on that. And temperature, of course, and composition means chemicals in that. So there are 4 counts here. Number 1 is water content. Number 2 is density. So water content, density, and then you can say temperature and composition. Water content, density, temperature and composition. These factors count for thermal conductivity. This means thermal conductivity is depend on moisture content of soil, bulk density of soil, temperature of soil and composition of soil. Temperature is never constant and composition may also change. I am not saying that confirmly, but it may. For a soil in place, composition and density are fixed. Composition and density, let us assume these are fixed, and temperature typically varies over a narrow enough range to have only a small effect on thermal resistivity. This is not case if soil freeze during cold months. Now what actually it says, now main variable for a soil in place is therefore moisture. Main variable moisture, because it is affected, it evaporates or it can come in by rain. So main variable for soil is in place or in location is moisture, water content. Purpose of thermal dry out curve is to represent effect of soil. To represent effect of soil, moisture content on thermal resistivity. This section details a can say simple method for developing a soil thermal dry out curve. In this file you will find there is a photograph also, one photograph of soil and a photograph of some test being conducted on site, and that photo is there. You can say it's a photo, and soil sampling being conducted in Walker branded water shed, name of that is, and this was a 1973 black and white photo, just for your reference. And it says also that some laboratories take as received RHO values to check against calculated curves. This photo is soil sample gradually air dried. This photo, there's one photo, soil sample gradually air dried. This is brown color sample. You can see in the file page 17/29 bottom, and on right side of this is 1973 sample being taken, testing being conducted. Now let's start it, creating a dry out curve. What's procedure of that? Let us see. Creating a dry out curve. In this it says prepare, number one is prepare a soil sample. You have to prepare a soil sample at least 5 centimeter diameter. 5 centimeters, very small of course, diameter, and 10 centimeter height or deep. So 5 and 10 centimeter diameter is your soil sample. Now you have to prepare by coring undisturbed soil. When you take sample from site during exploration, you just take by coring without disturbing sample of soil, or recompacting a soil. You have soil, you recompact it, recompact soil sample to desired density. Of course, size is there. You can change. You expect some density for test. You can have desired density in this case. So we will link it to these 5 points here, and you will see how it works. Now this was point number 1. Now point number 2 is saturate sample. You have to saturate this sample, whether taken from site undisturbed form or you make in laboratory by compacting soil to dry expected or desired density. Saturate this sample with water by placing it in a pan of water. Pan of water around 9 centimeter deep. So that is depth of pan, 9 centimeter deep, and allowing it to stand overnight. Whole night you put that sample in water by placing it in a pan. So pan water is there and your sample is in that. Pan is nothing but, like you can say, a trough. It's a kind of circular trough or other trough. Then number 3 point is, we have 1 point here seen, number 2 point we have seen water is being saturated overnight, and number 1 is preparation of that, either in undisturbed form from site or making it by compaction to desired density. Now 3 is insert thermal needle. We talked of thermal needle. 2 thermal needles, what was 2 meter deep for site purpose with 8 mm diameter, and other one is 1 meter, and I think I forgot thickness of that. I'll remind you. There were needles we talked yesterday, and those were here. Just let me remind. My memory is a little weak, so I cannot say guaranteed. What I'm saying is that yes, it is a 200 centimeter long and 2 meters long and 8 mm. That is site usable, and other one is 1 meter by 2.4 millimeters, and that is for lab use. So we can do that. So this is now what I'm saying. So what I say is here, number 3 is insert thermal needle. Insert thermal needle probe into sample and take a thermal resistivity reading. So it is in laboratory, so you would do that by 1 meter in 2.4 mm. So you weigh a sample and record weight and thermal resistivity. So you have both points here. Your thermal resistivity, that you are using needle probe of 1 meter long and 2.4 mm diameter, and also you are measuring weight of the sample. Both you are recording. This is your number 3. Number 4 is place the sample in 105 degrees Celsius over to fully dry it. Means you have to dry it out now, so because it was saturated in water throughout night, and it had to be now yes, it has to be dried out, so place sample in a 105 degrees Celsius oven to fully dry it out. Number 4 it is. And number 5 is cool sample. You have to cool the sample to room temperature. Means after drying, you have to keep in room or laboratory room and let it be dried at room temperature and take a thermal resistivity measurement and weigh. So that same which you took in saturated form, that thermal resistivity, you use this in saturated form, right? It was number 1, and then it was number 2, and you have to keep water. Number 3, you have to cover needle probe, so a saturated sample, you put thermal resistivity and weight. And now it's your dried out sample, you have to take thermal temperature and take thermal resistivity test, and then go in room temperature, and of course measure its weight. So you have these five points, 5 steps, which is sample related. And now you have to see what all these are. And now I'll see this way. It says from weight measurement, say from weight measurement, compute density and water content when wet. From weight measurement that you have taken, compute, because you got weight, can find density and water content when wet. This set of measurement fixes 2 points on dry down curve with direct measurements. You can then interpolate curve between these 2 points using an equation from Campbell 1985. And what is that equation? Very interesting equation that is. Let us see, there are so many parameters in that, and we have to understand these parameters. Okay. Now this equation is Campbell 1985 decided this equation, then discuss this, and this is RHO, that is resistivity, thermal resistivity RHO, in brackets given unit in meters Kelvin per watt, which equal to, there's one numerator, there's one is in numerator over A plus B theta. B O or theta, I'm not sure. I think O, I think it looks like theta, but it's O probably. Plus A plus BO bracket B minus A, and then bracket 1 minus G. Now where it says this O is a volumetric water content, maybe theta or O exactly, it's not clear. Let us say this is BO, maybe O is volumetric water content, that is volumetric water content, that is meter cube per meter cube, m cube and m minus 3. Well, this is really surprising how it can be meter cube per meter cube. Okay. Volumetric content is water content, so volumetric water content is meter cube of its water, meter cube per meter cube of soil. This could be unit is now understand, it's meter cube of water meter cube of water and per meter cube of soil. It's like that. That's water content. 1 meter cube of soil, and let's say 100 gram water is there, or 200 kilogram water is there, you can say, because you are taking per meter cube. So per meter cube, you can say so many percent of the water you can find from here. So I think that's the one. And we go further. Constants in equation are determined from measurements. And what are those? Let us see. It's saying D is a constant here. A is already there, so D is a constant here. D equal to, that is 1 over RHO dry. We know what is DRHO dry by probe when sample was dry. So we take reverse of that value, that's 1 of RHO dry. So we can say D is there, 1 over RHO dry. We got this value of D. Now, what is value of B? B equal to, it's here, B and over there. So what's value of B? B is 2.8 5. 2.85 equal to 2.8, no, small delta rho B over rho S. B and S, what does it say? Now where rho S means in denominator, rho S is m cube, m minus cube. So this is that m cube, m minus cube means meter cube per meter cube is solid fraction of soil. Solids fraction of soil. So in 1 meter cube, what is solid fraction? That is soil. Rho soil, density of that solid of soil. So this is solid fraction of soil. And rho B is measured bulk density, that is gram per centimeter cube of sample. That is, so we have here rho solid, that is solid part of soil, and rho B, that is bulk density of soil, G over centimeter cube of sample. And this rho S is particle density, solid is particle density, that is generally assumed to be 2.65 gram per centimeter cube. Now, so we have this, you can say, particle density and generally density. Now term G, this term G is used there, is discussed below, but has a value of 1. This G has a value of 1, and G, that is gram per centimeter cube. Term G is discussed below, but has a value of 1 when soil is wet. When soil is wet, and when soil is wet, so from equation 1, from equation 1, which is equation 1 is that equation 1. This is equation 1, that is RHO and bracket mk over w equal to 1 over a plus b, o plus d minus a, 1 minus g. So this is equation 1, and then equation 2 is equal to d equal 1 over RHO dry and equation 3 is b equal to 2.8 s equal to 2.8 OB or OS. Now it says in equation 1 and measurement at saturation. Now equation 4 is A equal 1 over RHO, the RHOW as T, that is wet, minus BO wet. This is equation 4, where RHO wet is thermal conductivity of wet soil. So these are 4 equations. Now, I'm sorry, I have to take more water. Now, and here is there, since we have gone through that, so we now move to here, and it says now function of, now we are talking next page, this page 19/29, function G, that function G we took over there, goes from a value of 0 for dry soil to 1 for wet soil. This is if G equal to 0 and this O or theta is equal to 0 are substituted into equation 1, we get RHO equal to RHO dry. RHO equal to RHO dry. If G equal to 1 and theta is equal to, we had said that are substituted, RHO equal to RHO wet. So RHO equal to RHO dry, RHO equal to RHO wet. Function G is computed from equation 5, which is G equal to 1 over 1 plus theta over theta O to power minus 5, where theta is a cut-off water, theta as it is cut-off water content for liquid return flow in soil. Read more about critical water content. Function is shown in figure 6. Now, cut-off water content can be estimated from clay fraction of sample using equation. Now, equation 6, this is equal to, that's equal to 0.3073 MC plus 0.0334. If clay content is not known, it can be estimated from soil texture using following table 2. Clay content, of course, varies within a textural class. Cut-off water content given by equation 6 is also shown in table 2. Now, there is a note here, units used in equation 1 are mk per W, watt is anything, multiplied by 100 to get degrees Celsius, centimeter per watt. So this conversion of mk per watt and into multiplied by 100 to the centimeter per watt. All that stuff. Now we go to the same again, this graph here on page 1929, and this graph is actually table 2. It is figure 6. Sorry, this is figure 6, and this is figure 6. That is liquid return flow of 3 soil type. And then table 2, typical class, typical clay, fraction, critical water content, and air dry water content, value for common soil texture. This is in table, and that is in figure 6, which I am showing here in graph. On top, that is water content, meter cube per meter minus cube, and there are 3 curves on this. On abscissa is water content, that is water content is content, and that's bracket meter cube per meter cube minus meter cube, and this is on abscissa. On ordinate, this is 0 to 1.2, and you can say 0 to 1.2, this is This is liquid, liquid return flow for 3 soils. What is liquid return flow from 3 soils? And that's going to see. One is here. This is called, I don't know what's in, liquid return flow for 3 soils, and this is from 0 to 1.2, and one red at bottom. One is red, that is clay, red curve. One is blue, sky blue, that is loam, and one is sand, which is little different color. So let us, this color here, which water content is from 0 to 0.5, 0.1, 0.2, 0.3, 0.4, 0.5, and there's up to 0 to 1.2, 0.2, 0.4, 0.5, 0.8, 0.1, and 1.2, which is a scale of what liquid return flow for 3 soil types. So in one, this is sand. If you see at origin starts 0, it goes to 0.0, it goes to 0.02, and then moves up to 0.6, 0.06, goes to 0.8 approximately, and then on 0.28 goes up to about less than 1, and then completely goes to 1, flat up to all. Similarly, sky blue curve same with the distance. Here you can say there's increase in water content, while in first case, in this case of sand, there's no such requirement here. Now here is it, you can say water content is increasing in case of loam, and also water content is increasing in case of clay, but curves are down in case of clay, and this loam lies between sand and clay. So draw, the water increases, and means water increases means your return is flat, comes down. In all these 3 cases, sand is stronger, its water content is less, and its value on this portion is higher. So this is here, where here is thermal conductivity, etc. G is discussed below, but as value of 1 when soil is wet. So soil is wet. So for equation 1 and measurement at saturation, all this is there. So this is this curve for dry out curve. So this is result of that. Means 1 is final in that case. This is in sand, and that 1 starts at water content 0.1 something, and in case of loam, it 1 starts at 0.21, so to 2 something, and in your clay, the 1 starts at 0.5. So this is what your graphics say. Now this is a liquid return flow, and then table 2, a typical clay fraction, critical water content, and air dry water content values for common soil textures. Here's the table we just talked of. Figure 1 is a liquid return, and here we are talking of table that contains 4 columns as usual. Before it was name is one column, first one, and which are sand, loamy sand, sandy loam, and sandy loam, sandy clay loam, loam, sandy clay, silt loam, silt, clay loam, silty clay loam, silty clay, and clay. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 types of soil are shown here. Let us say sand, then loamy sand, and then sandy loam, sandy clay loam, and loam. Right? Then sandy clay. So what's the loam? Sandy clay. Then silt loam, then silt, clay loam, then silty clay loam, silty clay, clay. Now second column is clay fraction, G over G, and in third column is critical water content, meter cube per meter cube, and air dry water content, W. What it says, in sand case, this is G over G, that is 0.03. Next is critical water content, that is meter cube per meter cube, 0.043. that is not very high. That is for critical water content, and that is for sand we are talking. And then there is air dry water content, W, air dry AD, G over G. So it is air dry water content is 0.003. So you see clay fraction, sand is clay fraction, and that is 0.03, and air dried case is 0.003. There is a division of 10 in this, and critical water content is 0.043. Means there should be more water, and critical water content you are talking, and air dried is very less water. You can say negligible water, and clay fraction is this. This is clay fraction, that is 0.03, and 0.03 means 3%. You can say that is sand, and clay fraction is that. In sand, clay fraction is 3%, and critical water content is 4.3%, and air dried water content is 0.03%. So now loamy sand, loam sand. Now clay fraction is 0.07, or you can say 7%. In loamy sand, clay is 7%. Now critical water content in loam sand is 0.055, 5.5%. It is in loamy sand, it is more than sand, right? In sand is 4.3, here it's 5.5, and air dry water content in this case is higher than sand. In loamy sand it is 0.005, or you can say 0.05%. Now sandy loam, it was loam sand, now sandy loam, there is a loam and sand is there in that, and let us say in this clay fraction is higher, 0.10 or 1%, means higher than sand and higher than loamy sand. This is sandy loam. In this case, you can say critical water content is 0.064, that is 6.4% higher than loamy sand. And here dry air dried water content is 0.048, 4.8% higher than previous others, sandy loam and loamy sand and sand. If we go to loam, now, that is loam clay content is 0.18. So loam is clay content 0.18, which is 18%. It's not 1.8, it's 18%. This is loam, and here water. Here water content is 0.089 or 8.9%, much higher than all previous types. And air dried water volume is 0.335, that is 3.5% lower than sandy clay loam. Now sandy clay, here you can say in this clay percentage is 40%, I'm sorry. Sandy clay is 40%. That is here you can say water content water content is, you can say here, critical water content we're talking. In case of sandy clay, critical content is 0.156, 15.6%, and it's higher. And this is in case of air dried sample, it's 0.068 or 6.8%. Now silt loam, it's 15%, 0.15 contents and clay contents, and then critical water content is 0.079 or 7.9%, and silt of this air dried one is automatic. Air dried one is 0.033, 3.3%. This is you can say air dried drought, you can say that we call it our technical terms. You can say that was dry out curve, and this is dry out value. Now we go to silt, and salt clay content is 0.077%, and its critical water content is 0.055, 5.5%, and it's dried out. Dried moisture is 0.058, 5.8%. Clay loam, and then silty clay loam, that is 0.33, 3.33%. The silty clay loam quantity of clay, and then critical water percent 0.135, it's 13.5%, and it says dried out sample moisture, which is 0.055, 5.5%. And now silty clay is 0.45, 45% clay, and 0.172, which is 17.2% critical water content, and 0.068, that is 6.8 dried out curve. Okay. And after that, clay, and this is in clay itself is 60%, 0.6, and its critical mass content is 0.218, is 21.8%, and its dried up water content is 0.0787.8%. So if you see these figures, in these figures you can say all these soils are covered. Now we move to now, this is another one. This is a page. Now this is measure is keep things to keep in mind. That's very important point. There's a photograph on the right side of this page, 20 or 29, and finding average at maximum. This is a photograph with photo is sun sets on cold ground scarred by ice and tire tracks. Okay, ice and tire tracks. This is just a photo. Sunset's time at sunset on cold ground scarred by ice and fire tracks. Finding average at max. Now, oven dry versus air dry. Things to keep in mind. What it says actually, we have the oven dry versus air dry. So I hope you might be having some interest in this talk if you are a technical person. Oven dry versus air dry. I'm sorry. Some water. All right. Says in thermal dry out equations that we studied at length. In thermal dry out equation, RHO dry value is for oven dry soil. This water content is lower than is ever encountered in nature. Its value therefore should not be considered. Resistivity of naturally dry soil. There is a table 2 that gives approximate values for air dry water content of soil. Soil in place shall almost always have higher water contents than already the air dry ones. One exception might occur if trenches excavated and fill allowed to dry for an extended period of time on soil surface before it is replaced. It would always be wise to wet fill around a buried cable, both to increase its density and to reduce its resistivity. A little moisture goes a long way in decreasing resistivity at at dry end. So a little water moisture goes a long way in in decreasing resistivity at at dry end. Also note that high water content matching point does not need to be at saturation. Methods for clay soils. Methods for clay soils. This is swelling clay. Swelling clay soil shrink. Swelling clay soils shrink and crack as they dry out. Such soils present spatial problems for methods outlined here. They wet or saturated measurement can be made outlined here, but dry measurement needs to be done in a different way. It's hard to give methods that will work in every situation, but dry resistivity of these soils can sometimes be measured by taking a clod or bed of dry soil. Carefully drilling a hole for probe, inserting probe with adequate thermal grease and making measurement. Finding RHO at maximum density and temperature conservations. These are finding RHO at maximum density. Good. Some exercise. Finding RHO at maximum density. One would often like to know thermal resistivity of a sample packed to maximum density. Once optimum water content for maximum density is determined using standard methods, a sample at optimum water content can be packed and its thermal resistivity determined. Good. One would often like to know thermal resistivity of a sample packed to maximum density. Once optimum water content for maximum density is determined using standard methods, a sample at optimum water content can be packed and its thermal resistivity determined. This becomes what wet matching point means maximum density you have and you have to determine its water content, optimum water content, thermal resistivity of a sample packed to maximum density, optimum water content for maximum density is determined using standard methods. Sample at optimum water content can be packed and its resistivity, its thermal resistivity determined. This becomes temperature of considerations. This becomes wet matching point. Temperature considerations. Let me open this shot for something. I'm not getting here. Let me get some air. Come on, get lost. Temperature considerations. This is page 21 of 29. Dry out curves using these procedures are for temperature at which measurements are made. Temperature has little effect on saturated and dry soils resistivity, but significantly affects resistivity of soil at intermediate water contents. Says temperature has little effect on saturated and intermediate water content it has. Again, known as a scratch on my waste. For resistivity of soil at intermediate water content, see figure 4. Thermal resistivities at temperatures other than room temperature, either detailed models or a full set of measurements must be used. This interpolation method given here for creating thermal dry out curves. Okay, our place I say dry out curves using these. What's happening to me? Dry out curves using these procedures are for temperature at which measurements are made. Temperature has little effect on saturated and dry soil resistivity, but significantly affects resistivity of soil at intermediate water contents. So figure 4 is there. Say for thermal resistivity at temperatures other than room temperature, either detailed models or a full set of measurements must be used. Interpolation method given here for creating thermal dry out curves will not work. Says that This interpolation method given here for creating thermal dry out curves shall not work. Figure 7 is there, we have to see is that. Thermal dry out curves report. A report set RHO, reporting RHO, this is page 21 or 9, 29 M4. This is reporting RHO. Figure 7 contains portions of an actual thermal dry out curve report. For more information, please visit. Okay, now figure 7, thermal dry out curve report. This is that curve. Let's see. I will open this. Result of ASTM D5334-08 thermal resistivity testing and thermal dry out curves. Thermal resistivity was measured on 2 soil samples from using Decagon KD2 Pro thermal properties analyzer with TR1 sensor in accordance with ASTM D5334-08. 2 samples received under RMA 13547 were identified. Hereafter refer to B2 and hereafter refer to B3. Alright. So a little slow, but it's very intellectual. Let me dry out my street also. My thermal resistivity. My thermal resistivity, I will check. Why not drying out my dry out curve I am making? Dry out all sweating. All moisture go. I don't want you there. I want optimum, not even optimum, I don't want moisture on my skin. This is also soil mechanics, my body soil mechanics. %85% humidity. Oh, 85% humidity. Can you sit in 85%? Fans? I put extract funnels on in bathroom so that at least some dehumidification is possible. Well, each sample was measured. Each sample is hereafter. B3 it is given, B2 and B3 we have to refer to as B3 and B2. Now, each sample was measured at as found in density and thermal resistivity. Density and resistivity, thermal resistivity. Measurements were conducted at native volumetric water content, volumetric water content, native volumetric water content, VWC, that's volumetric water content, over on dry and saturated VWC, volumetric on dry. So each we will see on drive and saturated volumetric water content. Now KD2 Pro was configured in high power mode with 5-minute read time for moist samples and a 10-minute read time for oven-dried water content. (10 minutes) read time for oven-dry water content and 5-minute read time for moist samples. Accuracy of TR1 sensor and associated KD2 Pro unit was verified using a Darling plastic. Samples measurements: wet, thermal dry curve using Berlit cap. Now I think I don't have complete table here because of this curve here, volumetric curve. This table was superimposed on that. I'm sorry, this figure was superimposed on that. What this figure says, let me concentrate on that because this table is not visible on this page. And this is a B2 thermal dry out curve. This is saying that VWC, that is VWC just says volumetric water content. Volumetric, this title of curve is B2 thermal dry out curve, and it has on its abscissa VWC, volumetric water, that is saying as just now we said volumetric, says VWC, volumetric water content on abscissa, and that's meter cube per meter cube, and R B is centimeters per watt. That's R is 3. C is degree Celsius. We can say this is now there are two. Now one is VWC and other one is RH. R is 2. VWC is 0 to 0.7, 0, 0.1, 0.2, like that up to 0.7, and then it is 0 to 900 on other curve, 0 to 900 degrees Celsius, centimeter per watt. What to do now? And it says that if VWC, that is meter cube per meter cube, is in case it is 0 VWC, then it is 800 on RH. Alright, so VWC is 0 means it is 800 on degrees Celsius, centimeters per watt. RH cube, C centimeter per watt. It's 800, and it is now. When this VWC is, it's now resistivity is that much, you see. When it is 0.1, it's 0.1, it's down, to somewhere, around 300 and or less, then it's 0.2 or 20%, can say, it's further down, and it's down up to 0.65, 6%. Life is like that. What to do? So we are now moving to other one. If we say it is going down and down and down, and it is at 0.65 VWC, this value is 100. Now what it says, interpolated RHO 6 degrees Celsius centimeter per watt measured RW. So this is interpolated RW and measured RW are differently. This is a tryout curve, right? Interpolated RHO centimeter versus centimeter per watt, and measured is centimeter per watt. There are some comments here. Says what? B2 sample. Why it's difficult to sit on this chair sometimes, early. B2 sample measured here had the lowest bulk density. It's the way of exercising while walking. B2 sample measure, B2 sample, right, this again coming this line. B2 sample measured here had lowest bulk density of soil sample received to date and is well below range of bulk densities normally found in mineral soils. Sample also had distinct origination with a gravelly sand for top half meter of sample and a fine textures yet still low bulk density material for bottom half. Low bulk density is cause of an exceptionally high thermal resistance. Let me repeat this comments here. It's an important one before I move to next, because thermal dry out curve with comments are important to everybody. B2 sample measured here had lowest bulk density at mercy of soil sample received to date and is well below range of bulk densities normally found in mineral soils. This sample also had distinct, can say, distinct horizontation with gravelly sand for okay, so the lowest bulk density normally found in mineral soils. This sample also had distinct horizonation with gravelly sand for top half of soil sample and a finer textured yet still low bulk density material for bottom half. Low bulk density is cause of exceptionally high thermal resistivity. Low bulk density is cause of exceptionally high thermal resistivity values for sample. Now we go to low bulk density is the cause of exceptionally high thermal resistivity values for this sample, which are far higher than what would be expected in a normal mineral soil. Now this is IE Guide for Soil Thermal Resistivity Measures, ESA book series limit. Now this is not my headache. Page 22 of 29. Structure. Now we go further. We go to studies, and that is page in studies, wind farms, data centers, public utilities, underwater cables. Power engineers Keith Lane and Scott Luna Carbon and associate spoke to yes, but how ignoring can samples. Okay, I'm getting this page now. Page is this says these cases are in litigation because of failure. Now studies, we go further here. This is on page 22 or 29. As I said, wind farms, data centers, public utilities, underwater cables. Power engineers Keith Lane and Scott Thomas of Carbon and Associate spoke to us about how Okay. Now go to studies now. S1. So one was M just mention or S study, and this is winds form. What it says, let us say wind forms. So here T, M, and this is studies. Good. Page 23 or 29. A few years ago, I participated in soils field trip. I'm not saying author is saying. One of sites visited was southern or the southeastern Washington, where hundreds of wind power generators have been installed. Group asked why some of generators were not working, and were told that underground cables connecting those generators to grid had burnt out. Operators said Operators said wind blown soil loess LOES, that makes up that area a bed. Now it says burnt out. They makes up had burnt out. Operators said wind blown soil that makes up that area had especially high thermal resistivity. They claimed that this fact was not known until problem with burned out cable emerged. Thermal properties of this soil, and not unusual. In fact, they are well understood. Well understood by soil scientists. Real problem was one that many of you likely have encountered. Soils information usually isn't sought as part of design. People may start asking questions when problems arises. And then can say after that, real problem was one that many of you likely have encountered. Soil information usually is not sought as part of design. The people only start asking questions when problem happens or arises. That approach, of course, is an experience on Charles. Alright. Then Thermal, they claimed that this fact was not known until problems with buried cables emerged. Pani, need I pani please? I'm feeling drowsy. Still I have to go long way, more than an hour. Now, they say people only start asking questions when problems arise. That approach, of course, is an expensive one. This is written by Campbell, 2008. Now, this photo, there's a wind farm, and there's wind farm sitting atop the rolling hills of Palausi. And this is another photo of blue color, and that's cable racks at Grid Computing Center. Formula blue lights. So this is a cable racks at Grid Computing Center. This is formula with blue lights, DOE 2007. This is page 24, 29. And it says we will tell them now. The same is coming here, previous one. It first says that. It says from paragraph it says 9, and they say we tell them this is a real thing. If you don't account for condition, you have a failure. I have acted as an expert witness in cases where original designer assured a thermal RHD of 90. These cases are so where or is going to say, you tell them this is a real thing. If you don't account for this condition, you have a failure. I have acted as an expert witness in case. I'm not browsing, I'm just thinking of what the person saying. Means the actor is expert, and he said that witness in cases where original designer assume thermal RH of 90, these cases are in litigation because of failure And one solution to problem to be extremely conservative. That's be extremely conservative design of this type of design grammatically used. Alright, that's any litigation can I do in that case. So one solution to problems to be extremely conservative in design, but type of design dramatically and unnecessarily increases cost. In this is also most businesses cannot accept that expensive expensive grass over design. Lane and column have instead done work to understand factors involving in complete Neher McGrath readings and 3D modeling works. They are then we go to next one. Now says page now 25 is public utilities. It is public utilities, page 25. Let's see. Just a minute, please. Let me relax a little. Page 25 is the utilities. In February 1998, a series of 4 power cable failures blacked out New Zealand's most important commercial district for nearly 5 weeks. I think we discussed this. Official investigation into failure cited improper ampacity rating on buried cable. Says soil and geographical conditions have a major influence on performance of cable, and for this reason these conditions need to be monitored. In particular, data is needed on soil temperature and soil resistivity because these conditions can change over time. It may be necessary to also change supply capacity rating of cables over time. I think I'm going to end this soon because these conditions can change over time. It may be necessary to also change supply capacity rating of cable over time. Now both gas and oil cables were installed in soil conditions which did not allow cables to achieve their specified rating. Mercury had a impact. that two oil-filled cables, two oil-filled cables were fully reliable to their full amount. Two oil-filled cables are fully reliable up to their full nominal rating of 60 MVA. M stands for megavolts ampere. In fact, rating of these cables was much lower due to ground conditions. In which they were buried. When they were loaded to more than half their nominal rating had, they would when they were loaded to more than half their nominal ratings, they would have started to overheat. Once cables were installed, most of these issues would not be detected. By conventional routine cable maintenance practices, and there are grounds to believe that mercury energy generation, mercury energy in that case, you can say Mercury's false sense of security is confirmed by an apparent lack of precautions that other operators may have taken following failure of two gas-filled cables, Auckland Power Supply, failure 1988. And this is page 27-28. After that, this is now page 26/29, London. In London, investigation, they found RHO of silt in bottom of canals to be as high as 118 degrees Celsius, centimeter pot. Weight, and that even higher values could be reached in presence of heated cables. Okay, then we go to over this, Lake Champlain. Lake Champlain 115 kilowatt cables were installed in 1958 and failed in 1969, 11 years, at a depth of about 300 feet. It's failed 1958 and not then Lake Champlain 115 kilowatt cables were installed in 1958 and failed in 1969 at a depth of 300 feet 100 meters. Sample of soil near failure was sent to laboratory for analysis. They found silt to have in that case, a sample of, when it was 300 feet or 100 meters, a sample of soil near failure was sent to lab for analysis, and it was found the silt to have an average value of RHO 90 to 100, even though silt was not tested in conditions that it was in lake bottom. And then you can say they found silt to have an average value of RHO 90 to 100, even though silt was not tested in condition that was in a lake bottom. New cable rating was based on take bed silt to have a RHO of 140 degrees centimeter per second. Even though it says that new cable rating was based on lake bed silt to have a RHO of 140 degrees Celsius centimeter per watt, thus Tuesday 2003. Now there's a photograph again here. You can see that photograph below this. You can see that. Let's before that you can say same data, same precision. It says on switchgear and failed conductor insulation, it's just a matter of time until you have a catastrophic failure. I have seen pictures of 2-year-old switchgear that looks like it is 100 years old, adds Lane's partner Scott Thomas. It's that, you can see that. Lane and Carbon agree that even now quite a few electrical engineers are just not aware of these issues. We always start by educating our clients. Lane can see a photograph here. Electrical page 25, transfer station, they call transfer station the substation with high line and say when we go to 26 underwater cables. Underwater cables. This is page 26, Denmark. What's written about that? Put off light. I put off light. Denmark, in situation described in Denmark, it was stated that cooling conditions for submarine cable are normally assumed to be very good, and ampacity is based on low value of thermal resistivity of time of seabed. Since land section had a thermal resistivity of 43, land section had a thermal resistivity of 43 to 54 degrees Celsius centimeter per watt, it was assumed that value of seabed was equally as well. After two joints failed in services, it was discovered in laboratory investigation. It was discovered in laboratory investigations that sea bed material contained high organic levels and thermal resistivity was 105 Celsius centimeter per watt. Alright, then we go to seabed contain this much, and needle probe into seabed discovered RHO 94 degrees Celsius. So thermal resistivity was this much, RH was this much. If you go to other one, that is see from here. This photo of offshore wind park at Baltic Sea. We go then to I think Lake Champlain is over, then 27 I think reference is only 27 and 28. Then I think this one, what we studied in this file, this question here, we studied in this file thermal resistivity, and this is measure it, don't guess. We studied this file, let us just have a review of this. We studied thermal resistivity, heat transfer capability through a substance by conduction. There's then one chapter on this preface, then is never use. So we studied in this thermal, look at variables and thermal research with this, and it simply says thermal resistivity of porous materials. What is that? We looked into many tables just to know many tables and many graphics about particularly three soils, and there is loam soil, quartz soil, and organic. What's the difference between the temperature and resistivity, moisture content resistivity, all these, and the other sketch in circular form. And also we studied about water contents in outside, all these points we have studied. Similarly, we studied so many descriptions. There were points we had to avoid about these issues. That soil impacted by temperature or by heat, by water, all that. Density effect we have seen. Density effect, RHO related, and all those effects, moisture effect, density effect, and the level, this dry out curve we learned, and all that, dry out curve and sensation side. The application practice in field, but it's there. And the two-way test, and this all the thermal resistance we understand from this point of view, how to compare a level test, how to compare its written water and all these tables, standards, and this we understood very well. I think we should have a degree of understanding now that thermal resistivity, electrical resistivity got certain relation to soil. Maybe we didn't realize this fact before, that we have to understand table temperature, relative soil, and all this obviously are temperature effects, and this is particularly in where this is in more distance. Alright, now we go to other one. So we have gone through this file. This file is also available, you can see on this URL, and you can see this file yourself, and I've just given my explanation to you about this file. Now in continuation to this work, I like to move to another file which is very important from engineering viewpoint, and that must be known to everyone. And that file I think is, let us see, we'll open this file. I'll go to my computer details and find this file is also very important. And that is interesting one as well. Though I've not gone through that, I'll read and explain to you. I'll not go through that one certainly, but I open this one. Let me see, soil. It's my directive soil is here, and this is Morillonite I'm talking of. You know that, but you know that name wise, not by something, by just come here. It is come here, Morillonite, effects of Morillonite, and that is page, how many pages on one of 17, other one is one of 33. Let's start this one, Morillonite, an introduction to properties and utilization, intact open, I think this is file name is, an introduction to properties and utilization, and it is in fact this is I think a part of a book. This is www.intecopen.com, books, etc. Mount Morillonite in relation to properties and utilization. So I'll go to actually share this chapter abstract, and it may be what is written in this. It's written share this chapter, and it's written here. Or it says, I will start. This is page number 217 here. Page number 217. It says Mount Morillonite. I'm going to discuss. We will be clear about that. Very important point from every point of view. I'll discuss these two files first, not today, maybe another time, and then I'll take another two files of Mount Morillonite. Then we'll jump on the report. And of course, abstract is clay mineral is an important material. It says clay mineral. Clay, we are talking of clay minerals, an important material available in nature, with an increasing understanding of clay structure. Now, Mount, it says Mount Morillonite is realized viable for an enhanced performance in variety of materials and products in areas of catalysis, food, additive, antibacterial function, polymer, sorbent, etc. Significant development in use of and applications of Mount Morillonite is seen in recent time. Now, an overview of Mount Morillonite structure and properties, and particularly discusses its recent utilization in important material. Mount Morillonite is introduced in terms of natural sources. Its chemicals, structures, physical and chemical properties, and functional utilization. Important physical and chemical properties are summarized as particle and layered structure, molecular structure, and cation exchange effects, barrier property, and water absorption, followed by important functional utilization of Mount Morillonite based on effects of its chemical structure. Important functional utilization of Mount Morillonite includes food additives for health and stamina, for antibacterial activity, and gum decay, and sorbent for non-vomit anyway, and cationic dyes. Now, cationic dyes and used as catalyst in organic synthesis. Environment concerns to date do not indicate adversity for particles used as additives. Studies useful which are clearly based on Mount Morillonite structure to desired environmental effect. Okay. I'll repeat this paragraph because this is preliminary paragraph. It's telling something so that we should know that this file is a little widened, so I find difficulty in moving over this. Let me little blow it down back so that I can read it fast, It's now clay mineral is an important material. Clay mineral is an important material available in nature. With an increasing understanding of clay structure, Mount Moronites realized viable for an enhanced performance in a variety of materials and products in area of catalyst, food, additive antibacterial function, polymer, sorbent, etc. Significant development in use and application of Mount Morlite is seen in recent times. This chapter provides an overview of Mount Morlite structure and properties, and particularly discusses its recent utilization in important materials. Mount Morlite is introduced in terms of natural sources, chemical structure, physical and chemical properties. Right. This chapter provides an overview of Mount Morlite structural properties and particularly discusses its recent utilization in important materials. Mount Morlite is introduced in terms of natural source, chemical structure, physical and chemical properties, and functional utilization. Physical and chemical properties are summarized as particle and layered structure, molecular structure and cation exchange of fat, barriers property, and water absorption. This is foiled. This is followed by importance of functional utilization of Then you see important physical and chemical properties are, as I say, summarized as particle and layered structure, molecular structure, and cation. Okay, then we say sometime I have to wait because my eyes problem. You should realize that fact. This font is too small and I can't take strain of this. So the important physical and chemical properties summarized as particle and layer structure, molecular structure and cations, exchange of fat, barriers property, and water absorption. This is followed by important functional utilization of Mount Morlite based on effects of chemical. Oh my God, where is my mouse from here? chemical structure. Important function utilization of malt include food additive for health and stamina. That's a problem, yeah. Health and stamina, for antibacterial activities against tooth and gum decay. So as absorbent for for anionic for absorbent for non-ionic, non-ionic, anionic and cationic dyes, and use as catalyst in organic synthesis. Environment concerns to date do not indicate an adversity for particles used as additive. Studies will be useful which are clearly based on any non-maltic structures to describe environmental effects. Now, chapter of the information. Now, information. Historically, clay mineral has long benefited human life. Historically, and civilization being an integral part of Earth, its history is older than creation of man. Divine script of holy, divine script. Yeah, I'm not going to that. Holy, can leave it. In times of technology, well, leave it. I'm not concerned that. Now, science of clay was introduced since prehistoric times, and ceramists used the nanoparticles since antiquity. I'll leave this also, not interesting history. Now we are going to this table. Clay mineral may be grouped in 4 types shown in here. Group members were mainly in layered structure. These are now that's a common character of clay mineral. A common character of clay mineral is a fine-grained natural structure. Fine-grained natural structure in a sheet-like geometry. This is clay. You know that. बाबा चावल यहाँ से यार क्यों ये लगा के बैठ जाते हैं, बस फोटो लगा के बैठ जाते हैं, प्रॉब्लम करते हैं मुझे यार. So what we say, a common character of clay mineral. A common character of clay mineral is a fine-grained natural structure in a sheet-like geometry. In a sheet-like geometry, sheet structured hydrous silicate. Sheet structured hydrous silicates are generally called phyllosilicates. Phyllosilicates. PHYLLO silicates. Phyllosilicates. This is a sheet structure. Natural clay particle is smaller. Natural clay particle is smaller than 0.004 mm in diameter. That may range from 0.002 to 0.001 mm for quartz, mica, feldspar, iron and aluminum oxide. Colloidal clay particles are finer and found in layered silicates less than 0.0001 mm. So start right 0.0001. Group members Group members vary mainly in layered structures. These include kaolinite group, ismatite group, montmorillonite group, illite group, and charoite group. What these chemical groups are? Let us say, let me drop it down further. Can't solve. It is group name kaolinite, smectite, illite, and then it is, there is fifth one, fourth one, I missed some there. Pillar, this is charoite, and then chamusite. Well done. Now, group is 1, and this is kaolinite, Kaoli, and we read this before. Again, I'm just giving you member minerals. This is kaolinite, dictite, nectite. That general formula is Al2 Si2 A5 bracket OH4. This is chemical formula of this group, mineral group. This is kaolinite. I'm just refreshing something we studied in another book. This is Al2 Si2 Al2 Si2 O5 OH4. Members are polymorphous composing of same formula and different structure. 2 is smectite. This is montmorillonite. Smectite, Smectite, montmorillonite, pyrophyllite, talc, and vermiculite, sauconite, saponite, nontronite. This is, these member minerals. This is in smectite. Okay, then we go to this smectite, montmorillonite, pyrophyllite, talc, vermiculite, sauconite, saponite, nontronite. General formula is Ca, Na, H in bracket, both bracket Ca, Na, H, calcium, soda, and hydrogen, and then Al, Mg, Fe, Zn bracket 2, and then Si, Al bracket 4, O10, OH bracket 2, XH2. So how many are there? Montmorillonite is first one maybe, and prophyllite, and this is vermiculite, and saponite, that. Now X indicates varying level of water in mineral type. And then can say illite. Illite is KH bracket Al2 Si Al4 O10 OH2 etc. Then we say X indicates varying level of water and mineral type. X here, XH2O, varying level of water and light. Then illite is KHL2SiAl4O10OH2 XH2O. Wherever H2 is coming, X is coming. X indicates varying level of water in mineral type. Then amsite, MgFe 4Al4 Si44. This MC, this is MC. Then Kukit, this is chlorite, and this is Kuketi, Li2 Si2 O10 OH2. Each member mineral has a separate formula. This group has relatively seven. Now we have to see if we can do 347 or problem. Can move on this. It is now there's a table here, major groups of clay minerals. So what does it say? Major group of clay minerals here are major group of clay minerals. This is page 317. I'll give this a file, I think, in share better, screen share. I'll give this file, that's better for you people, and I can just speak that on that. Major group of clay minerals. Kaolinite group has 3 members, including kaolinite, dickite and nacrite. This advanced file actually. Formula for kaolinite group is Al2Si2O5 and bracket OH subscribe 4. Then illite group is represented by mineral illite, only common clay type. In general, the formula for illite is K, comma H, bracket Al2, bracket Si, Ai, and comma. Okay, then we go to illite group is represented by mineral illite, only common clay type. General formula for illite is K, HL2, SiAl4, O10, OH2. XH2O, it's an important rock forming mineral and main component of shale. Main component of shale. Structure of this group is similar to montmorillonite group with silicate layers sandwiching an aluminum oxide hydroxide layers in same stacking sequence. This group is similar to that. So this is a very important table actually. Uh, Chlorite group, chlorite, CHLORIT, chlorite group is relatively large. This group is not necessarily considered as part of clay, therefore it's placed at a separate group in phyllosilicate. Family member in chloride groups are mesite, chamosite, cocaite, and daphlite, with varying formula and structure. There is no general formula. Variety of clay minerals is based on arrangement of tetrahedral and octahedral sheet. For example, 1:1 clay mineral would have one tetrahedral. 1:1 clay mineral would have one tetrahedral and one octahedral sheet. Per clay layer 2:1. Clay mineral would contain two tetrahedral sheets and two tetrahedral sheets and one octahedral sheet sandwiched between two tetrahedral sheets. So actually reading is a problem here. Well, octahedral sheet adjacent to 2:1 layer, as says that one octahedral sheet sandwiched between two tetrahedral sheets. Mount Molynite is an example of clay mineral having 2:1 sheet structure, and 2:1 clay minerals are composed of octahedral sheet adjacent to 2:1 layer sheet structure for layer of various clay minerals with possible change in shown on. Then you say here is a list of this class of minerals, and that is clay mineral group. This is layer type and layer charge. These are columns in this. So what it says, number 1 is kaolinite. Number 2 is montmorillonite or smectite. Then illite, vermiculite, chlorite. Now this is mineral group, and layer is in kaolinite it's 1:1. In montmorillonite it is 2:1. This is octahedral and tetrahedral, whatever I'm talking about. Then illite is 2:1. Vermiculite is 2:1, and the elephant is also. Hmm. Kaolinite, montmorillonite, halite, vermiculite, calorite, so many groups, and I said kaolinite 1 is to 1 and its layer charge is less than 0.01. Montmorillonite is 2 is to 1, it's 0.5 to 1.2, and that's layer charge. Elite is 2 is to 1, layer charge 1.4 to 2, and vermiculite is 2 is to 1, 1.2 to 8, and chlorite is 2. That's variable. This variable one. Now this is table 1. Table 2. Sheet structure for layers of clay minerals. What does it mean? That is, I think you're getting my point. I'm talking of clay and different minerals which are in the structure in the soil. What's that? If you understand that point, it should be very helpful for you. Many foundation, Now we go to another one, that is I still have time about, I think maybe 1 hour I take. Is पढ़ने का बहुत क्या करूँगा यार यार. Sheet structure for layer of clay minerals. Let me blow up a little here. I can't read this. Let me blow up a little. No problem. I can move here and there. Now sheet structure, we just read class. I read class again because this is little difficult. I'll read table 1 again. Nature groups of clay minerals, and kaolinite group has 3 members, including kaolinite, dactite, and nacritite. Formula for this is Al2Si5 O5OH4. Elite group is represented by mineral elite, only common clay type. General formula for elite is KHAl2SiAl2 O10OSU-XH2O. It's an important rock forming minerals and similar to and main component of shale. Its main component of shale, that's very important. Shale is what? You know what shale I'm talking of? It's a very important component of shale, and shale means structure of this group is similar to montmorillonite group with silicate layers sandwiching and aluminum oxide hydroxide layer, and same staging appears. The shale rocks, in USA there are shales rock where they got petroleum available. Now they have closed that. Shales rocks are here in that. Chevron and other company, ExxonMobil, I think Exxon, they have to pump out, bail out offshore. And now this is structures of this group like similar to montmorillonite group with silicate layers, sandwiching aluminum oxide hydroxide layers in same stacking sequence. Chloride group is relatively large. Chloride group is relatively large, is not necessarily considered as part of clay. Therefore, it's placed as a separate group in phyllosilicate. Members in chloride group are mesite, chamosite, hookite, and delphite, and varying formulas of structures. There is no general formula. And then variety of clay minerals. Variety of clay minerals are based on arrangements of tetrahedral, and octahedral. For example, there are sheets I'm talking of this tetrahedral, octahedral sheets, and for example, 1:1 clay, say 1:1 clay mineral would have one tetrahedral and one octahedral sheet per clay layer. 2:1 clay mineral would contain two tetrahedral sheets and one rectangular octahedral sheet sandwiched between two tetrahedral sheets. Sandwich means octahedral shall be sandwiched between tetrahedral sheets. That is morillonite is an example of clay mineral having 2:1 sheet structure. And 2:1 clay mineral are composed of an octahedral sheet adjacent to 2:1 layer, and the sheet structure for layer of various clay minerals with possible change is shown in now. There are mineral groups, say 1, 2, 3, 4, 5. One is kaolinite, other is montmorillonite, smectite, and other is illite, then vermiculite and chlorite. That's chemical minerals, and layer type is in kaolinite 1:1 means 1, and montmorillite 1:1 means 1:1 that is tetrahedral and octahedral, and montmorillite is octal and tetrahedral 2:1, illite is same 2:1, vermiculite 2:1, chlorite is 2:1, then layer charge is point with less than 0.01, and 2:1, otherwise 0.5 to 1.2, and 2.20 that is layer type 2:1 is 1.4 to 2, and 2.3 is equal to 1.2238, and then we go to here, let's say illite is 1:1, 2:1, 1.4 to 2, and this is vermiculite is 2:1, 1.2 to 1.8, and chlorite is 2:1, and variable. Now table 2 sheet structure for layers of clay minerals. Table 2. Table 2 is saying, this is sheet structure for layers of clay minerals. Natural reserves of montmorillonite are present in various parts of the world. That is sheet structure I am talking of. Natural reserves of montmorillonite are present in various parts of the world. An earliest discovery of montmorillonite was indicated in 1847 in Montmorillon in Vienna Prefecture. In Montmorillon, that's location, Montmorillon in Vienna Prefecture of France. However, use of montmorillonite for medicinal purpose may be in over 200 cultures, including ancient Egyptians, pre-Aztec, Amargosians, natives of Mexico, South Americans and North Americans. Names used for montmorillonite are known in different languages, including montmorillonite, Portuguese, Catalan, and Spanish, montmorillonite Dutch, and montmorillonite German, Hungarian, Slovakian. Major montmorillonite deposits found at 5 places include Himalayas, China, Urals, Pakistan, Caucasians, Georgia, Russia, Andes, Peru, Ecuador, and Wasatch, UT, USA. Now, bentonite. Bentonite is an important rock of clay. That is, bentonite is an important rock of clay found in nature. It's an important source of montmorillonite in nature, and that's called bentonite. Is an important rock of clay found in nature. It's an important source of montmorillonite in nature. It's a rock formed of highly colloidal and plastics clays, mainly composed of montmorillonite. In addition to montmorillonite, bentonite may contain some amounts of crystalline quartz, crystallized and feldspar. Variety of bentonite applications are result of its useful and interesting chemicals and physical properties. This range of properties include rheology, solvent effects, plasticity and lubricity, high dry bonding strength, and then you can say it's just some historical background I am giving, so little reading is a problem for me actually. Very like, but there's another way. A variety of bentonite applications are a result of useful and interesting chemical physical properties. The range of properties include rheology, solvent effects, and plasticity, lubricity, high dry bonding strength, high shear and compressive strength, impermeability, and low compressibility. Natural bentonite. Yes, natural bentonite particles are indistinguishable. Natural bentonite particles are indistinguishable from kaolin clay minerals. Kaolin clay minerals viewed under scanning electron microscope. sorry. So in general, clay minerals are distinguishable from kaolin, bentonite, and clay minerals viewed under scanning electron microscope. However, main difference indicated was thickness. Sodium or potassium salts of bentonite exfoliate into thin plates that could be 1 nanometers in thickness theoretically. In general, clay mineral based on bentonite may exhibit in properties of thixo- thixotropic gel formation with water sign. Mm. Mm. However, main difference between thickness, sodium and potassium salt of bentonite exfoliate into thin plates that could be 1 in thickness theoretically. Generally, clay minerals based on bentonite may exhibit properties of thixotropic gel formation with water, high water absorption, and high cation exchange capacity, CEC, cation exchange capacity. These properties could be varied in clay minerals depending upon nature of interstitial water, and exchangeable Cartesian sections in interior layer place. And then no, bentonite, which mainly contains Montmorillonite, was discovered in about 1890 in USA, and its name bentonite is associated with name of an American geologist for one time Fort Benton. One time Fort Benton is eastern Wyoming rock. Creek area, USA. Montmorillonite derived from bentonite. Montmorillonite derived from bentonite may contain sodium or calcium. Sodium montmorillonite is main fraction in bentonite, found in combination with 10 to 20% various minerals, including feldspar, calcite, silica, and gypsum. Physical structure of montmorillonite particle is generally perceivable in sheets and layers. Each layer is composed of two types of structural sheet. I then say physical structure of monomodular particle is generally perceivable in sheets and layers. Each layer is composed of two types of structural sheets, octahedral and tetrahedral. Tetrahedral sheet is composed of silicon oxygen. Tetrahedral linked in neighboring tetrahedra by sharing three corners, resulting in external network. External network. So then say in hexagonal network where is gone? Hexagonal network, yes. Remaining fourth corner of each tetrahedron forms a part to adjacent octahedral sheet. Octahedral sheet is usually composed of aluminum or magnesium in six-fold coordination with oxygen from tetrahedral sheet and with hydroxyl. Two sheets together form a layer and see you can say octahedral sheet is usually composed of aluminum or magnesium in six-fold coordination with oxygen from tetrahedral sheet and with hydroxyl. Two sheets together form a layer. Several layers may be joined in a clay crystallite by interlayer cations by van der Waals force by electronic force. By hydrogen bonding. Theoretical formula and structure is indicated in important natural physical properties of monomer argument in best field indicates are softness, colloid air. This is ML2 MgSl 4Q10 OH2 NH2, and this is figure 1 theoretical formula and structure of monomer source number nano USC. So I'll take this possibly. Let me say if I can. But it should be a part of your file later on, but let me just do sketch of this for your purpose. Better to do something that way. I think it should be. Let me just take a sample of this. This is structure here. So it's not कैसे आ गया यार, सही नहीं है ये बात, it's not right. सही नहीं है, सही नहीं है दोबारा बोलो. So it's that we are here running in sorry to America. This is that. This is monocrystalline structure here. Okay, let's see this. So let's do this. I'll go this way. Come on, then go to. No, it's say. Let me see. Other one is. If you go further, say figure 1, theoretical formula and structure of monocrystalline source nanocore INC IL USA, and now it's let us serial number, property term name, and this is something like that. It says this is table number figure 1, and then table 3. Let's say serial number 1 2 3 4 5 6 7 8 7 8 9 7 8 9. Property name is density, then crystal system, then hardness, then fracture, then cleavage, luster, transparency, and color. These are there. Let's see how it works. It says density is 2 to 3 gram per centimeter cube. This is a measured one. So density is 2 to 3 gram per centimeter cube. This is a measured one. Crystal system is monoclinic. Hardness is 1 to 2 on Mohs scale. Soft passes fine-grained occurrence. Fracture irregular, uneven. Cleavage is perfect. Luster earthy, dull. Transparency translucent. Color white, buff, yellow, green, rarely pale, pink to red, presence of high valence amine products, pink to red, coloration. There's another table 3 now. Important natural physical properties of montmorillonite. Important natural and physical properties of montmorillonite, page 417, and this says that variation in chemical formula of montmorillonite is possible resulting from modifiable structure. cation substitution in cation substitution in, introduces charge imbalance. Therefore, chemical composition can vary. Exact theoretical formula is never seen in nature. However, structure in nature, in whatever form, consists of water molecules. Chemical formula for Montmorillonite discovered at Montmorillon, France is Ca 0.14, Na 0.02, bracket sum 0.16, bracket Al 66, MgO dot 36, and Fe 0.004, bracket close, then sum 2.0 equal to 2.08, bracket Si 3.9, Al 0.1. So already got there. Then we can say it's continuous here, 208 bracket Si 3.9, Al 0.1, bracket close, sum 400 O10 OH2 1.02 H2O. Oxide composition comprises silicon and aluminum oxide. However, it was predominantly calcium Montmorillonite discovered at Montmorillon. Dominant fraction were SiO2 and Al2O3. Now we go to oxide composition comprises silicon and aluminum oxide. However, it was predominantly calcium Montmorillonite discovered at Montmorillon. Dominant fractions were SiO2 and Al2O3, whereas SiO2 was slightly more than 50% of total cores. Total oxides, Elementary molecular structure is based on units comprising silica tetrahedra and aluminum octahedra. So silica tetrahedra and alumina octahedra. Cation Si4 is fourfold and possesses tetrahedra coordination with oxygen, while cation Al plus 3 occurs in sixfold or octahedra. Coordination. A layered structure is influenced by presence of charge. A layered structure is influenced by presence of charge in tetrahedral and octahedral sheets. Isomorphous substitution in clay mineral mainly produces charge. Isomorphous substitution is a basement of an attempt Then you can say here, let's go there. Yeah. Elementary molecular structure is based on unit comprising silica tetrahedra and aluminum octahedra. We have gone through this. A layered structure is influenced by presence of charge in tetrahedra and octahedra sheets. Isomorphous substitution in clay mineral mainly produces charge. Isomorphous substitution is replacement of an element with another element in mineral crystal without modifying its chemical structure. For example, Al3 plus can replace Si plus 4 in tetrahedral coordination, and replacement of Al3 is possible by Mg2 plus and Fe2 plus and Fe3 plus octahedral reactions. Tetrahedral coordination and replacement Ai3 is possible by Mg2 plus Fe2 plus Fe3 plus in octahedral coordination. Sheet present in montmorillonite are composed of 2-1 structure. Sheets in crystal plane have a negative charge and hydroxyl group linked to aluminum and magnesium. Electrostatic force is primarily force of attraction between two sheets, however, it is fragile. Montmorillonite and introduction. Okay, now chemical composition, ionic substitution, layer structure, and particle size of natural clay minerals have important role in creating a variety of minerals and specific characteristics. However, sheet structures are used to classify clay minerals, and chemical composition was used for nomenclature. Montmorillonite in nanoclay. Then we go to, let us say, montmorillonite in nanoclay. Montmorillonite in nanoclay. Montmorillonite in nanoclay. Montmorillonite is basic raw material used in production of nanoclay. Chemically, it can be described as hydrated sodium, calcium, aluminum, magnesium, silicate hydroxide. It can be described as hydrated sodium, calcium, aluminum, magnesium, silicate hydroxide, bracket NaCa, bracket closes 0.33, bracket AlMg2, bracket Si4O10, bracket OH2 NH2O. Interaction between nanoclay particles and polymer matrix significantly depends upon hydroxyl group and changes present in nanoclay particles. In clay polymer system, clay nanoparticle can be intercalated or exfoliated, where clay crystal is used as nanoparticle. It can be referred as intercalated clay. In this case, polymer chains are between clay platelets, and when single particle of clay is constituent unit, it is transferred as exfoliated clay. Platelets are isotopically dispersed in polymer. Important required important required access in clay. Alright, it's really tedious, I gone through that. So in clay polymer system, clay nanoparticle can be I think I've gone through this now. Intercalated or exfoliated, where clay crystals used as nanoparticle can be referred as integrated clay. In this clay, polymer chains are between clay platelets, and when single particle of clay is a constituent unit, it is referred to as exfoliated. Clay platelets are isotopically dispersed in polymer. Important required characters includes particle size, surface area, and aspect ratio. I'll repeat. In clay polymer system, clay nanoparticle can be intercalated or exfoliated. Where clay crystal is used as nanoparticle, it can be referred to as intercalated clay. In this case, polymer chains are between clay platelets, and when single particle of clay is constituent unit, it is referred to exfoliated. Clay platelets are isotopically dispersed on polymer. Important required characteristics include are particle size, surface area, aspect ratio. Length and breadth of particle can range from 1.5 micrometer down to few tenth of a micron. Third dimension of particle study is described as thickness, width, or diameter. However, diameter may be used. Diameter of particles exceptionally smaller relatively to the length, measuring to only 1 billionth part of a meter. This is 1 nanometer. Therefore, an extremely high average length to diameter ratio called aspect ratio, length to diameter ratio 200 to 500 is achievable. An increased aspect ratio is higher surface area. A smaller mass of nanoclay shows a high surface area. For example, typically 1 gram of nanoclay product is known to have a surface area in excess of 750 meters square. That is an equivalent area to nano soccer fields. Nanoclays are available containing over 98% monazite. Variable colors are result of substitution of interlayer cations by iron, titanium, and manganese within lattice structure and depend upon level of substitution and violence state of cation. Montmorillonite required to be surface modified to become organophilic and easy to disperse in polymers. Organophilic Montmorillonite is produced using organ cation substitution. Progress in study to modify structural composition of Montmorillonite to its processing and surface treatment may be indicated by achievement of 40 patents issued to one commercial organization. Montmorillonite nanoclay has experienced a variety of utilizations. Montmorillonite nanoclay is indicated as a drug carrier system and is as an additive. Montmorillonite composite for application in drug system can be produced through utilization of anionic, cationic and non-ionic surfactants to enhance basal spacing, resulting in organic clay to be used in drug loading and drugs release. Important aspect in a drug carrier system including drug entrapment, molecular level interactions analysis for a sustained drug release and targeted drug releases are reviewed. This review discussed various aspects of Montmorillonite nanoclay such as structure properties, multifarious applications and results of biocompatibility studies. Significant rich intercalation chemistry of a reduced cost is an important reason in producing Montmorillonite polymer nanocomposites. Such hybrid materials, also termed as polymeric nanocomposite (PNC), received extensive interest in research and industry. PNC, that is polymer nanocomposites materials on a nanoscale level, exhibit advantageous effect in mechanical properties, here distribution, distortion, temperature, thermal stability, flame retardancy and enhanced barrier properties. Commercially, several desired effects obtained in PNC are resulting in an increasing consumption of Montmorillonite. Combination of improved properties including weight reduction and low cost in final product resulted in important commercial applications in automotive and packaging and so on. Significant findings in Montmorillonite polymer non-composites are received for material type elastomeric thermosets and polymer form natural resources on. Natural resources of biopolymers. Volume of recent research literature clearly indicates interest and growing consumption of clay minerals, particularly Montmorillonite. In addition to natural Montmorillonite application, studies are concentrating in development of Montmorillonite as nanoclay, organophilic clay through modification in its physical and chemical structure. Utilization of nanoclay is discussed in following sections where performance effects of montmorillonites are described. Now we are on page 5, and then it is functional properties, cation exchange property, then it's electrical conductivity, and then it is two main. We'll see them. Let me see where do we stand now in time. It's 4:47:12, and if I take 10 minutes more, 10-15 minutes more, I can do that. Well, so let us see electrical cation exchange property, functional properties. Cation exchange capacity is a property of soil introduced by clay and organic matters. Its capacity of soil to hold cations, generally Al3 plus Ca2 plus Mg to Mn2 plus Zn2 plus Cu2 plus Fe2 plus Na plus K plus H plus, and described as quantity of positively charged ions held by negatively charged surface of clay minerals. It may also be termed as cation exchange capacity, Cc, that may be measured as centimole positive charge per kilogram of soil or milliequivalent of positive charge per 100 gram of soil. Fine-grained particles of clay result in an increased surface area per unit mass. Smaller particle size 0.002 to 0.001 mm in diameter results in a significantly higher surface area where a large number of cations can be adsorbed. These adsorbed cation impart significant level of electrical conductivity in clay. Ionic substitution in sheet structure produces useful modifications. Ion like Fe3 plus Al3 plus are small enough to enter tetrahedral coordination with oxygen and substitute. Similarly, cations like Mg2 plus Fe2 plus Fe3 plus Li1 plus Ni2 plus Cu2 plus can substitute Ia3 plus in octahedral sheet. Large size cations such as K plus Na plus C are located between layers and referred as interlayer cations. Electrical conductivity, and this is also this was cation exchange property, and this is now electrical conductivity. Clay particles. Are porous materials. Pore fluid influence electrical conductivity. Electrical conductivity meter second per minute of a porous material is combination of electrical conductivities of matrix material and pore fluid. Air, water or saline water may be present in pore. When air, water or saline water may be present in pore when pore fluid is of low conductivity. For example, air or water. Both the conductivity of clay mineral is contributed by matrix material. Pore fluid having a higher electrical conductivity significantly enhances the total electrical conductivity of clay. For example, clay particles with a significant porosity level 40 to 50% and saline water present in pore. Both the conductivity is mainly contribution of pore fluid. In this case, there would be negligible difference on conductivities of sand and clay. In higher content of clay particles with 2:1 structure present in Mount Morgellonite sample produces an increased bulk electrical conductivity for non-saline soils. Effect was attributed to exchangeable cation or to proton transfer from dissociation of interlayer water's content. A reduced level of interlayer water content in saturated clays resulted in lowest electrical conductivity. Since clay contains pore fluid, clay type, saline water and water saturation influence soil conductivity, assessment of electrical conductivity of reservoir rock may be used to estimate these factors. However, variation on distribution of liquid and solid phase introduce variation and complication in electrical conductivity of heterogeneous porous medium. Distribution of electrical ions around pores is called membrane polarization. In membrane polarization, negative ions are oriented to one end of pore under influence of DC potential across clay pore, and this polarization and resist current flow. In study of soil, clay content in soil can be determined using electrical conductivity and membrane polarizations as functions of clay content. Then heat resistance, then we will see heat resistance. Montmorillonite is a good heat insulation, and heat resistant effects are obtainable using it as an additive in any substance. This is an area of significant research to produce thermal barrier effect in composite material structure. Thermal barrier properties of clay mineral had been used in heat resistant and flame retardant applications. Nanoclay is currently used extensively and investigated in polymer composite to obtain an increased thermal stability and flame retardancy. Variation in expansion under heat effects for metals, polymers, and ceramic and been noted. Generally, order of thermal expansion magnitude in polymer metal and ceramic may be indicated as follows. Heat resistance follows. It says that polymer, metal, ceramic. This relation order is based on values of linear thermal expansion coefficient, which are in range of 20, 30, 20, 10, 10, 320, 35 ppm per degree for polymers, metal, and ceramic respectively. Therefore, an increased thermal stability of montmorillonite introduces its use as a filler in producing polymers to impart a low thermal expansion. However, enhancement in polymer thermal stability requires an increasing aspect ratio, and an aspect ratio of greater than 100 is essential. Water absorption. Water absorption is an important characteristic of the natural clay particle. Clay particles can absorb or lose water in response to changes in humidity contents in ambient environment. When water is absorbed, it fills the space between stacked liquid structure layers. Montmorillonite typically exhibits a gradual dehydration and phase change to stronger non-expandable clay. Specificity of type of clay is variable, resulting from loss or gain of water. Most of known clay types are available in nature as a mixture containing several varieties including carbonate, feldspar, micas, and quartz. Several studies address swelling behavior of montmorillonite. Interaction of montmorillonite with water introduces useful effects. Water molecules cause swelling in montmorillonite. Swelling is a result of complex montmorillonite water interactions between particles and within particle itself. Water molecules absorption and swelling of montmorillonite introduce hydrated state and hysteresis. The migration of counter ion initially bound to montmorillonite surface to central interlayer plane leads to swelling in montmorillonite. Therefore, change locus in montmorillonite has a strong influence on swelling dynamics. An important concern in clay mineral studies how monovalent and divalent cations affect swelling patterns of K plus and A plus Ca plus Ca2 plus montmorillonite. Montmorillonite is a 2:1 clay mineral. That's two tetrahedral sheets separated by one octahedral sheets. and montmorillonite platelets can be negatively charged when tetrahedral substitution of Si by Al into tetrahedral sheets. Octahedral substitution of Al by Mg in central octahedral sheet. In any of above two, in some of the cases, negative charge produced is compensated by interlayer ions, hydration in interlayer cation plus swelling. Small platelets stacking structure indicated as complicated to accurately characterizing through experiment. Therefore, in molecular dynamics simulation, MDS molecular dynamics simulation is a useful way of understanding atomic level structure. MDS is useful to study montmorillonite structure, including swelling and hydration of interlayer cations. MDS was performed for K plus Na plus Ca2 plus montmorillonite with a varying level of water content. Valence of cations showed significant influence on montmorillonite water system simulation. Simulation indicates that cation K plus shows too strong interaction with dehydrated montmorillonite sheets. However, in case of hydrated montmorillonite sheet, cation Ca plus interacts strongly. Therefore, layered spacing of simulated K plus, Na plus and Ca2 plus montmorillonite was obvious. Simultaneous measurements of swelling and swelling pressure was done using a researcher-developed cell undisturbed clay samples at a defined swelling 0 to 75% were removed from cell and analyzed using SEM, FTR and ATR micro attenuated total reluctance spectroscopy. Silicate SiO stretching region 1150 to 1950 centimeter -1 showed significant changes with variation in swelling and orientation. It was found that reduced particle size with increased swelling was related to increased misorientation of clay platelets. Rearrangement of clay platelets was observed as a direct result of breakdown of clay particles with increased hydration and then functional utilization. So now we'll see. We have gone through this. I'll take this later on because it's too late now. I'm sure that this is very interesting one, montmorillonite issue. This is not that easy as people understand. We have to study in further details. I would like to give these copies to you through screen share soon, so that you may be able to understand, because montmorillonite clay is very important from study point of view. Clay one, and that's dangerous for formulations all over the world. We have to be very careful about this, and it's in our interest that we understand this. And with this, I'd like to close it. This video today. It's of course I'm closing this file first because I have to close this. It's a very important one, and we have to be very clear about this. This is first I close YouTube. Thank you very much. I will meet again, and it's okay. It's fine. I close this one here. Then I'll give you here, and I open this file also. Despite that, thank you very much. I'll see you again here. And with this, I'll say that and video.